Hello all, my name is Krish Nayak and welcome to my YouTube channel. So guys, today in this particular video, we are going to have this amazing crash course wherein we are going to discuss about two key terminologies, which is called as loop engineering and harness engineering. Here, in this specific video, we are just not going to understand what is the meaning of loop engineering or harness engineering. We're also going to go ahead and implement two amazing end-to-end projects wherein you will be able to understand so many things. Make sure to watch this video till the end. Bappy, one of our instructor in Krishnayak Academy, he's going to probably take this entire crash course, right? So again, this video will be for somewhere around 3.5 hours. We have made sure that we have taught each and everything step by step. So please go ahead and enjoy this specific crash course. Thank you.
The topic name is loop engineering in agentic AI. Okay. So here I'm not only going to discuss about the theoretical concept of loop engineering. Apart from that, I'm also going to show you the practical demo of that. We'll try to build a self-correcting multi-agent system so that you can understand how loop engineering works, okay, internally, each and everything, right? Three types of application we usually develop inside generative AI. The first type is the prompting approach. Okay, prompting approach. So in prompting, actually, what we do, let's say here we have a large language model. This is our large language model, and here we give a prompt. Okay, and it returns a response or output, whatever you can say, right? So we call it as a LLM inference. Okay, and here LLM wise, we can use anything. We can use GPT, we can use Llama, we can use Gemini. Okay, we can use any kinds of LLM. Okay, you can use let's say Mistral. Okay, anything you can use. I think you know there are thousands large language models are available nowadays over the internet. We can use any kinds of large language model here. Okay, so if you have seen uh, the first let's say prototype of the application whenever it came in the market, especially whenever generative AI came in the market, right? So the first application got introduced something called ChatGPT, right? So those who have already used ChatGPT at the very beginning, I think you know that we used to pass a prompt, okay, in the ChatGPT, and ChatGPT used to return you some kinds of response. Let's say you are giving just tell me about Python. Let's say this is your prompt. You are asking, tell me about Python. So this prompt will go to the LLM. Now LLM has the knowledge cutoff. Knowledge cutoff means it has the knowledge base. That means large language model has trained with huge amount of internet data. So this Python information definitely it's available over the internet, right? So that time, let's say they train this model. So also Python information was available inside the model. So it will try to utilize that particular knowledge base and it will give you the response. Okay, this is the Python. This Python is a programming language. Okay, now we can use this Python, blah, blah, blah. Okay, this kinds of response you will be getting. So that means if you're asking anything to the large language model, if this particular knowledge sources is available in the large language model, that time it will be able to give you the response. Okay. Otherwise, it will directly tell you, I don't have the informations about the questions you are asking. Okay. I can't help you with that. So how many of you have, let's say, faced these kinds of, let's say, problem? Anyone here? So if you have already used any kinds of large language model, I'm not telling you any kinds of application, any kinds of AI agents application. I'm talking about only simple large language model application. So if you are asking anything, so let's say if I'm
So guys, before we go ahead, I would like to thank the sponsor of this specific video, Apodex. Um, I will be explaining you how Apodex can be actually used, and a huge shout out for them. Here's the thing about deep research with AI. After a few hundred steps, the context window congests, lines of inquiry collide, and the agent is basically proofreading its own blind spots. The real problem is the model reflecting on its own draft has the exact same blind spots that made the error in the first place. And that's what leads to pseudo correctness, reports that look professionalized but may stay factually wrong. So, today we have Apodex. the self evolving heavy duty solver. To research, solve, and discover at the frontier requires more than the model capacity. It requires rigorous reasoning, each step verified. So, Apodex is an AI system designed for complex and demanding research tasks. There are three levels of depth, which is provided by Apodex: the deep research, which is fast source grounded research across the full depth of available knowledge. And then we have the deep solve, resolve what matters. And finally, we have the toughest one, which is the deep discover, which generate what is new, the highest rigor, heavy duty solver for the hardest questions at the frontier of human knowledge. So Apodex fixes this at the architecture level. It's a heavy duty solver. Up to 150 specialized sub agents working asynchronously with independent verification agents. That did not do the reasoning. Deep Discover hits the browse comp with 90.3 and Frontier Science Olympiad with 87.4. The open models punch way above their weight. Apodex Deep Research, the 35 billion model, is topping Future X right now. And the small series at 0.8 billion, 2 billion, and 4 billion are the compact models trained on deep research SFT data alone. The 4 billion beats every open source 30 billion class model, which are all freely available on Hugging Face. Now let's try Apodex. So here we are predicting whether NVIDIA will maintain more than 70% of the AI GPU market share. Okay. And here you can see we have the three different options: the deep research, the deep solve, and the deep discover. So we'll be right now exploring the most capable one, which is deep discover. And as you can see that multiple agents are right now being dispatched. So it's right now in the research phase with multiple runs. Now, as you can see here, multiple agents have done their research, the NVIDIA current share research, then the AMD AI GPU research, the Intel AI accelerator research. So really, the first step is researching, and multiple agents are right now working. And finally, we can see that deep discover has completed. The reasoning has completed. It took around 35 minutes. Total 432 claims have been verified with 961 evidence. You can get the entire detailed run with respect to the research agent, the verification agent. It used 6 sub-agents for verification, 1 sub-agent, then the total number of evidences based on that, the claims that came. So it's pretty much a detailed one. And right now, as I can see that with respect to the competitors also, for every organization, I can say that it has been provided with a lot of detail. And finally, I can say that all the major references from where it actually got the evidences and finally looked into the claims. So all those are available in our final report. So I can say that this is really impressive. So this video is sponsored by Apodex. So try this solver now. Links in the description. Builders, go grab the open models. Stop proofreading your own blind spots. Go try it today.
Showing you, if I show you the open AI model list, okay, or any kinds of model list, you can simply open up. Okay, you can open up and you can see it is having a knowledge cutoff date. Okay, so let me show you, view all the models. So let's pick one model here. So let's say I'm going to pick this GPT-4o mini. Okay, I'll pick this particular model. Now, if I open this model, you will see that it is having some kinds of information. The first information is nothing but it's a context window. Context window means it's an input size of the model. That means at a time, how many tokens it can take as an input. Okay, that means this model can take this amount of tokens. Okay, then this can generate this. This is the maximum amount of tokens it can generate as an output, and this is the knowledge cutoff date. That means this model got trained till October 1, 2023. Okay, that means till October 1, 2023, whatever data was available over the internet, this model got trained. Okay, this model got trained, and this model is having the information till October 2023. If you are asking, okay, after October 2003, let's say you are asking tell me about 2026 FIFA World Cup. Okay, who won the World Cup, right? So definitely these kinds of questions your LLM will be able to won't be able to give you the response because it doesn't have these kinds of informations. Okay, so this was the main problem with this prompting approach. Okay, this was the main problem with the prompting approach. So that's why what researcher thought, let's say right now, if you see this data is getting updated day by day. Okay, in internet, every day there are some new informations are coming. So fine tuning this kinds of large language model is super hard, right? So we can't fine tune this kinds of large language model because it's expensive. We need a good instance, okay, that is powerful machine. Context learning or engineering, you can tell learning. We also call it as a RAG. That means retrieval augmented generation. Okay, I think you already know about this RAG, right? Cognitive augmented generation, we call it as a context learning as well. Okay. So in context learning, what happens? Let's say you are having your large language model. Let's say this is your large language model, LLM. Okay. And see, it is not only going to rely on its own knowledge base. Instead of that, we provide additional knowledge sources here. Okay. Provide additional knowledge sources. Okay. This is called knowledge base. And here we use a vector database. Vector database. Okay. And this vector database, we stores all kinds of new informations and we connect with the large language model. So whenever user is asking any kinds of question, okay, it is giving you the response with respect to this particular context, okay, or knowledge base. So this is called actually context. The information it is getting from the knowledge base, this is called context. That's why it's called it as a context learning or RAG, retrieval augmented generation. That means if user is asking anything, let's say if user is asking, tell me about, let's say, FIFA World Cup 2026, right? So that time, if this information is not available inside LLM knowledge base, let's say you are using GPT-5 here, or let's say GPT-4 here. This information is not available here. That time, what it will do? It will go to the knowledge base, okay? And let's say in knowledge base, we have already stored these informations about the FIFA World Cup 2026. So it will fetch these informations from the knowledge base as a context. It will pass to the LLM, okay? And LLM will try to refine the answer and it will give you the final response. Okay, this is called context learning, retrieval augmented generation. That means RAG. Okay, but what was the main problem with this retrieval augmented generation as well? The problem is that if you are asking anything real time, or if you are giving any kinds of automation, okay, automation means let's say you are asking to do, let's say, send a email to the customer A. So that time, this kinds of application won't be able to do that because it can generate the email for you, but it can't send the email because it doesn't have any kinds of automation tools, right? Or let's say another example I'll give you. If you're asking, tell me the current weather, tell me the latest news for 2 days. So this kinds of application doesn't have any kinds of tools that can use to fetch the real-time informations. Okay, this was the main problem with the RAG application. Okay, so that's why researcher again introduced another technology. We call it as a agentic AI. Okay, agentic AI or AI agents, whatever you say, right? So in agentic AI, what happens? You have your large language model. Everybody will be using large language model only, okay? But the types would be different. Now, this large language model is having your knowledge base connection. It's completely fine. Let's say we have connected with the knowledge base, completely fine. Even it will also have connection with the tools. Okay, it will also have connection with the tools. Now, what is the tools? Tools could be anything, any kinds of API, any kinds of database, any kinds of, let's say, tools. Okay, anything. Okay, anything you can call it as a tools. Okay, so let's say you want to send the email. So to send the email, guys, what I need Gmail API key, right? So Gmail API key, okay, would be one kinds of tool here. Let's say you want to send the message automatically to your WhatsApp. So WhatsApp API would be your tools. So that means whatever application we use, especially software application, every application having their developer side. That means the API. So you can API, you can use that API to perform some kinds of automations, right? So that's why these kinds of tools we provide to the LLM, right? That means this is our agent. Okay, this is our agent. Okay, we provide to the agents. Now, if you're asking anything, Now it will utilize that knowledge base as well as the tools. Okay. And it will give you the response. Okay. Now it is not only going to use that tool, it can also perform the automation. Let's say you are telling, just send the email to the customer A. Now, first of all, what it will do, let's say you will send this particular prompt, it will come to the agents. Agents will decide whether I have to generate this email from my knowledge base or I need some additional informations. Let's say I'm talking about this, let's say I'm talking about, let's say one website called Krishna.in website. So I'm telling, just try to send an email regarding our latest webinar to this particular student. Now, how it will get the latest webinar informations? Definitely, I will try to put these are the informations in the knowledge base, right? Okay, about the Krishna team. So what will happen? This informations will come to the LLM. LLM will try to read it and it will prepare our email. Okay, with the help of some kinds of tool. Now, after preparing this particular email, I also told this email should be sent to the learner, right? So what it will do, it will take the learner's email address and it will use the email API key to send that particular email. That means everything is being automated here. You are giving a single prompt and all of this process is getting automated. So this is the main benefit with these agentic AI applications. Okay. Now here, whatever tools technology we have used, we also call it as a harness engineering. Okay. I think you have also probably heard of this name, right? Harness engineering. So don't worry, I'm going to take another webinar there. I'm going to tell you about this harness engineering more. Just now, just try to consider whatever tools and technology we use, we try to integrate with the large language model, or sorry, with our agents, we call it as a harness engineering. So without tools, right? Without tools API, you can't create any kinds of agentic AI applications. Every agentic AI applications are using these kinds of tools and API, okay, to perform the automations. Right, guys, yes or no? Tell me in the chat, guys. Are you getting? It is getting clear, all of you? That means in generative AI, there are three types of application we usually create. The first type application we create called prompting based application. Okay, there we my voice is fine, guys. Voice is breaking. Just a minute, let me check. Now is it fine? I think it should be fine. I think it's clear, right? Okay, fine, guys. I told you there would be some kinds of like technical issues because this is an online seminar. Okay, so please let me know if you are facing any kinds of problem. Definitely, I'm going to fix that. Okay, so let's continue. So I told you inside generative AI, we create three types of applications. Okay, Uh, one is the prompting based applications. Then we only send the prompt. Okay, we try to use the prompting. So that's why at the very beginning you saw that whenever we got this kinds of generative AI technology, people used to focus on the prompt engineering. Okay, but nowadays, have you seen anywhere people are using prompt engineering? No, right? Because things are getting changed, right? Now we are using agentic AI applications. So the traditional prompting approach won't work, right? So that's why prompting has been almost not, I'll say deprecated, but yeah, this has become old, right? Yeah. Voice is breaking. Mm, I think my connection is also good. My connection is good, I think. Yep. Voice is clear too, right? Yeah, someone is still many people are telling voice is clear, okay, but some of you are getting issues. I don't know what is happening. Hmm. Let me check my mic as well. Yeah, mic is also fine, I think. Hmm. Now, guys, is it clear? Am I clear, right? Okay, fine. I think I'm clear right now. Okay. Now let's continue. So now what I told you guys, I told you in generative AI, there are three kinds of application we develop. One is the prompting, one is the context landing or RAG, and another is the agentic AI applications. Okay. Now you can ask me, okay, it's completely fine. We got to know in generative AI, there are three types of applications. Okay. We uh, we usually develop inside generative AI, but what is this loop engineering exactly? Okay, why people are talking about the loop engineering nowadays? I think if you open your LinkedIn, if you open your Instagram, right now you will try to see this kinds of loop engineering concept is very trending, right? Even on YouTube channel also, lots of creators are creating this kinds of content. Now let's try to understand what is loop engineering, whether it's a different field or it is the same thing we usually using. Okay, but we don't know about that. We'll just try to discuss this particular part. Yeah, I'm going to clarify all of your questions. Please be with me. First of all, let me clarify, okay, everything. Now let's try to see what is loop engineering. Mm, loop engineering. See, I'm going to give you the definition. Don't worry. First of all, let me just give you a high level overview about the loop engineering. Okay. Now see what happens. The same, the type 3 application agentic AI. I'll take this particular example only. Let's say we are having one agent. Okay, we are having an agent. Okay, and you know that it has a connection with lots of tools. Okay, tools with the help of these tools, it can perform some kinds of automations. Okay, and here we are giving the questions, and here we are getting the responses. Okay, now the simple AI agents we usually develop, it has the two connections only. One is the input, okay, and another one is the output. Okay, so this is the simple agent architecture we usually create. So that means if user is giving any kinds of input, these agents will decide, okay, it will use the large language model for the reasoning, and it will understand the user requirement. Based on that, it will select the tools, and with the help of these tools, it will generate that particular response, or it will perform some kinds of work, and it will give you the output, right? So this is what actually we usually create, okay, inside agentic AI applications. But this is not enough. Okay, if you're creating this kinds of agentic AI application, this is kinds of one shot agents you are creating. Why I'm telling as a one shot agents? Because you are giving an input and you are getting an output. There is a direct communications. Okay, there is no any kinds of verifications. Okay, so what happens in the real world? Let's say if I'm learning anything from my teacher, right? So definitely teacher will give me some kinds of task and I will complete that task, and again I will go to my teacher for the review. Okay, teacher will try to review the entire task, and he or she will give me the feedback, right? Let's say you have done a mistake here, or your work is completely fine. Okay, we can approve your work. So these kinds of feedback is needed whenever you are learning anything, whenever you are doing anything for the first time, right? If you're getting these kinds of feedback, if you're getting these kinds of suggestion, so it will help me a lot to learn that particular topic in depth. But if I'm directly getting the task, and if I'm completing and there is no verification, there is no marking, so now tell me, would it be good or bad? Definitely this is not a right way to learn, right? Anything. So that's why there should be some kinds of verifications, there should be kinds of feedback layer. Okay, so that whatever things we are doing for the first time, we get a feedback. Based on that, we can improve, either we can continue. Okay, now especially nowadays, those who are using any kinds of coding agents, I think you are using coding agents, right? Can you name some of the coding agents you are using in your life? So I think the first one you will tell, okay, sir, I'm using Cloud Code. I'm using VS Code Copilot. I'm using Cursor IDE. Okay. I'm using Anti Gravity. I'm using Codex. So what is this? Or what are these informations about? Okay. This information is all about, it's a coding agents, right? It's a coding agents. Even ChatGPT also we can consider, it can also generate the code. Again, we don't use ChatGPT for the coding purpose. Yeah, someone might be using that, but especially for coding agents, there are some kinds of software they have created for us. Okay. Now, if you have seen the coding agents, what coding agent does, let's say you are giving a prompt, just generate, let's say, a Flask project for me, or let's say you are giving, let's say, my name is P. I done a YouTube channel called DS with Bappy. For this, I need a website. Okay, just try to create this particular website for me. Now, what will happen? Your agents will start write the code, right? And it's not like that. Whenever it will start writing the code, and once code is prepared, it will directly give you the code. Okay, it's not like that. What coding agent does, once it has generated the code, okay, once it has generated the code or any kinds of functions, it will verify whether this code works or not. If you are generating any kinds of buggy code, okay, and if you're giving to me, that time your application is not good to me, right? I'm not going to use your application if you're giving a buggy code to me. So I can even write a better code than your applications, right? So that's why this kinds of application is having one verification layer nowadays. Okay, so what this verification layer does, whatever your agents are generating, let's say this is my codex, okay, or let's say this is my cloud code, it is here I'm going to draw another example. Let's say this is my agent. Okay. Here we're giving the input. And instead of directly giving the output, it is passing this particular output to a verifier. Okay, verifier. And what this verifier is doing, it is verifying whether the generated code or generated response is fine or not. Okay. If it is fine, it will give you the output directly. Okay. It will give you the output. If it is not fine, what will happen? It will generate the feedback. And again, this feedback will go to the agent. Okay, this is called actually feedback loop. Okay, this is called actually feedback loop. So this feedback loop will be running unless and until your agent is generating the perfect output for you or perfect code for you. Okay, so this is called actually agentic loop. What it called? This is called actually agentic loop. Okay, now I can show you one real-time example. If you go to the Cloud Code documentations and if you go to this code component called how Cloud Code works, okay? Now here in this particular sections, they have already discussed about this agentic loop. Can you see guys, agentic loop? Now here they have already told that whenever user is giving any kinds of prompt, okay? So what it is doing, it is first of all gathering the content, taking the actions, okay? That taking the action means it is generating that code for you, okay? Because Cloud Code is especially for the coder, okay? It will generate the code for you. So it will generate the code. So after generating code, it is not directly giving you, okay? Instead of that, it is trying to the another layer called verify layer, okay? And this verify layer will try to verify whether this generated code is fine or not, whether it is running or not, is there any bugs or not. If there is not any kinds of bug, it will directly give you. It will tell done. Okay, let's say this is your code, just try to use that. Or else, if it is found any kinds of bug, if it finds any kinds of issue, then again it will try to give the feedback to the agents. Okay, it will try the agents, okay, this is the feedback, it has these kinds of problem. Again, try to regenerate that particular code. Again, agent will take the actions. Okay, again it will generate something. Again, it will pass to the verification layer. Again, verification layer will check. If fine, it will send done. Otherwise, again it will go to the agents again. That means this is kinds of agentic loop is running. Okay, I think you have already studied about the loop in Python, right? How many of you have studied about the loop concept? I know you already know about loop, right? What loop means? Loop means you are giving a task which should be continuously running, and should be definitely a termination condition. If there is not any kinds of termination condition, this loop would be completely infinite. That means if you send a prompt to the agents, agents will run, I mean, infinite time. Okay. Your entire life you have to wait in front of your computer. Okay, so definitely there should be some kinds of interruption. Okay, that's why it is telling there should be some kinds of interruption. Either this interruption you provide as a HITL, that is human in the loop, either you can assign any kinds of condition, either you can give any kinds of maximum iteration limit. Okay, so this thing you will try to provide to the infinite loop. Okay, so that means inside a agentic loop, there are main two component. The first component is the verifier, the second component is the interruption rule. Get it, guys? Is the feedback consist of human in the loop? Krishna, I think you have now got it. Not only human, you can either use human, either you can write any kinds of condition. Okay, Either you can give any kinds of other, let's say, termination condition. It's completely up to you, your design pipeline. It's not necessary to always put the human verifications here. Okay. Okay. Because if you have already used coding agents, so coding agents, sometimes it will ask for the human input. If you're giving human input, again, it will run the loop. And once it found like, okay, this content is completely fine, that time this loop would be automatically break, right? Definitely one condition we know, which is that if our generated response is completely fine, okay, this condition, again, just try to understand this condition. Once this generated output is completely fine, there is no issue, this agent will break this loop, okay, because user will get the result and this loop would be break, right? But if it is not if it is not good, if it is having some kinds of issue, then this loop would be repeat again, okay. But there is a possibility every time your agents will generate some buggy code, okay, and it's not like that you have to always run this again and again, okay. So there should be some kinds of termination condition. In case, let's say, if your agents is not able to do it, there would be some kinds of termination conditions. Either you can give set any kinds of maximum iterations, either you can ask your human to stop that particular conditions for you, okay. Yeah, definitely it will use the tool to perform the actions, right, Krishna? Agents, always remember, agents means it has the tool connection. None of the agent, I mean, it doesn't have the sorry, none of the agents don't have the tools, okay. Every agents have the tool. Got it? So whenever I'm talking about agentic AI applications, definitely there would be tool connection. Without tool, we can create the agents, okay. Tool would be definitely there. Okay, now I think you have understand how these kinds of coding agent works, especially the cloud code. Then we have Codex, we have Cursor ID, we have my VS Code Copilot. Okay, whatever agentic, let's say these kinds of coding agents you are using, every coding agents use these kinds of agentic loop to give you this kinds of, let's say, free code, okay. It's not like it is directly generate, it's not like that it's directly generating the code for you and it is giving to you. Before giving to you, it is doing one kinds of verification with the help of verify, okay, and it is giving you the output. If this particular output is good, you will be getting the output, otherwise this feedback loop would be running continuously. This is what actually loop engineering is, okay. This is called actually loop engineering. See, this is nothing but our agentic AI concept only. Only the things they have added this looping concept. Okay, that means we are not going to trust one shot response. Instead of that, we'll verify that. Okay, just try to match with your real life. Whenever you are learning something, definitely you need a mentor, and mentor will give you the feedback. Okay, you are doing great, or this is the issue you are facing. Okay, or let's say this improvement you have to do. If you are getting this kinds of feedback, right, from the teacher itself, then you can do something good in your life. Otherwise, you don't know what is happening to you, right? Whatever things you are doing, you don't know whether it's right or wrong. So that's why one kinds of verification is required. So these kinds of verification we add inside loop engineering only, and we make these kinds of agent more powerful, and whatever output we are getting, this is more reliable, more safe. Okay, this is the concept of loop engineering. Is there one agents or one agent for generation, another agents for verifications? Exactly, Adil, you are right. Okay, now it not necessary to only use two agents here. There should be multiple agents. Let's say you are creating a blog writing agents, okay. Now in blog writing agents, what happens, one agents would be your topic research, okay, it will do the topic research, then it will pass to the another agents will try to research this particular topic over the internet, then it will send to the another agents will try to write that, okay. After writing, it will send this particular content to the reviewer agents, okay. Now reviewer is the verifier here, okay, it will review whether this particular resulted blog is fine or not. If this is fine, it will directly pass to the final response agent. Final response agent will provide the final format to the user. Otherwise, it will give the feedback to the where, to the again writer agents. Okay, it will give the feedback to the writer agents. Try to improve this, right? Okay, again writer agents will work. So this is called actually your agentic loop that time. Get it, guys? So it's not necessary to add one agents only. It depends upon your design philosophy, whether you are creating a single agents, whether you are creating a multi-agent system. Yeah, this session is recorded, Imran. Okay, it would be recording. So got it, guys. So far, everyone is clear. If you're clear, guys, please write clear in the chat, all of you. I want the confirmation from you. Then I will go to the next part. Let me know, guys, if you're clear till here. Okay. Now we'll try to deep dive into this loop engineering mode. Okay, don't worry. I've just given you high level overview. Now we'll try to understand. Okay, for this I have created a PPT for you. Okay, we'll try to go through this entire PPT and we'll try to understand about this loop engineering. Now let's open this PPT and let's try to understand about this loop engineering. So this is the PPT, guys. Don't worry, I'm going to share with you as well. Okay. Now see, guys, on my screen, I have already written the definition about this loop engineering. So as you can see, what is loop engineering? Loop engineering means designing an agent that repeatedly works, checks its result, learn from the feedback, and tries again until the goal is achieved. Now you are getting this definition, I think. But if I showed you this definition at the very first time, definitely you would have the confusions, right? That's why, first of all, I have given you that high level overview, okay, through this architecture. Now I think you can understand this particular definition. Okay, what is loop engineering exactly? Now instead of human continuously telling the agents, let's say, try again, fix this problem, check your answer, improve the output. Okay, we are using loop engineering concept. That means we are writing an agentic loop. We are integrating an agentic loop. Our agent itself is automatically correcting its own mistake. Okay, so see, the main issue with the chat gpt is it doesn't have the looping concept. Yeah, you can generate the code with the chat gpt, but it will give you one shot output, right? Let's say I need image classification code with the TensorFlow. It will give you the code. ChatGPT even don't know whether this code will work or not. So what it will do, you will just try to copy that code, run in your local machine, and you will face any kinds of issue. Again, you will copy the issue and you will tell your facts, ChatGPT to fix this problem. Again, ChatGPT will do some research. Again, it will fix that problem. Again, it will give some kinds of code. Again, it will run this code. If let's say this code is looks good with you, again it will tell try again or check your answer, improve the output. It will give different manual prompting. But we don't want that. We need some kinds of system. This will automatically work for me, right? So this is called actually agentic loop application, especially whatever coding agents we are using nowadays. Getting how it's the different from a deep learning model. Deep learning model is different. Okay, deep learning model means it's a predictive model, but here we are working with the generative model. Shibras. Is it very token heavy? Definitely. Whenever you are creating this kinds of, let's say, agentic loop, especially, it will cost more tokens than your simpler agents, because every time it has to take the output, it has to verify, it will give the feedback again. Based on the feedback, it will work again, will get the output. So this kinds of loop is going, right? So definitely, yeah, some, I mean, token heavy would be available. That's why this kinds of, I mean, coding agents is having a subscription plan. Okay, they will take good amount of money from you. Why? Because of this token. Okay, you were you are spending the tokens here, not anything else. So none of the coding agents are free nowadays. If you're using any kinds of coding agents, you have to pay for that. Okay. Yeah. Now let's try to see one example. Let's say in our traditional agentic application, not traditional, yeah, we see it's not like that you always need to add the verification layer inside your agents. It depends upon the problem statement. Let's say we're creating a coding agents that needs the verification. But if you're creating a simple, let's say let's say trip planner agents that will only plan the trip for you, this kinds of verification is not required. So I'll give a trip topic and it will do some research over the internet and it will give me the plan. Let's say I want to visit from Bangalore to Japan, right? So I need a trip plan, like in Japan, which place I have to visit, what kinds of food I have to eat, right? So these kinds of things we can easily do with the help of these kinds of agents. Okay, we don't need any kinds of verification layer here. So again, it depends upon your problem statement. If your statement needs the verifications, you can go with loop engineering concept. Otherwise, it is simple agents, whatever you have learned so far. Okay. So This is what your simple approach. That means if user is asking anything, agents is returning the answer in one shot. There is no verifications. Okay, you are getting the output and this agent is getting stopped, terminated. In loop engineering, in agentic loop, what is happening? User is asking a questions. Okay, it is going to the agents. Agents is generating something. This generation is giving to the feedback layer. Okay, feedback layer or verify. Verify will try to verify whether this particular result is fine or not. If it is fine, it will return, otherwise again it will return you the feedback. That means this loop will continuously run. Okay, great guys. So that's why a normal AI call usually gives one response and stops. Okay, that is fine for the simple question answer, but risky when the task has many requirement, especially the coding agents. Okay, a loop adds a checking stage. If the output fails, feedback goes back into the agents for another attempt. Okay, so simple idea: answer once, this is risky. Okay, but if you check and improve, this is more reliable. Yeah, Bhumika, you are right. Okay. Hmm. Now let's take one very simple example. I already taken that classroom example. Let's see if you are a learner. So first of all, your teacher will give you something, any kinds of task. Let's say you are giving exams. So after giving these exams, you are giving this exam paper to the teacher. Teacher is giving you some kinds of feedback, some kinds of improvement. You are again, doing that particular task. Okay, that's how we usually learn, right? Okay. Now we can see simple definition. Loop engineering means designing an AI agents that can generate work, evaluate the result, receive feedback, try again, and stop when the goal is met. Okay, that means generate, check, improve, repeat. So this is the architecture of loop agents. Okay. Now this is the classroom analogy I have already given you. Yeah. Now non-agent loop, let's try to understand. In non-agent loop, what will happen? User is giving a goal, it will generate once. Okay, return the answer, your agents will stop. There is no repetition, there is no looping, right? Example, write a customer support reply, so it will write a customer support reply and it will stop. Okay, but if you are using agentic loop, that time what will happen? It will write the customer support message. Okay, it will understand first of all customer, let's say intention, customer, let's say feelings. Based on that, it will write the message to you. Let's say someone is asking, sir, I need a career guidance from you. I'm not getting a job. That means this person is frustrated, right? So the way I have to reply to this particular letter, that would be kinds of different tone. But if I'm telling, uh, let's say I can't help you with that, or let's say go ahead and try to find a job. Okay, so this is not a right tone. So I have to understand the customer behavior, customer feelings. Based on that, I have to generate the response. Okay, so that's why if this kinds of response you are generating with the help of non loop agents, that time there is a possibility it will only generate this answer one time. It will not even verify whether this is perfect for this user or not, and user will not interest in your applications, right? It's better to have a verifications so that it will understand this output and it will verify, okay, whether this is matched with this customer or not. Okay, I hope you got it, guys. How feedback is given to the agents? I'll tell you this part. See, here you can understand, okay, how this feedback is going to the agents. Now see, whenever user is giving any kinds of input to the agents is generating something. Okay, and here you have the verifier. Okay, now if this particular answer is good, it will directly send you this output. Okay, otherwise this verification will give you feedback. Okay, feedback means it will check this output, and definitely the verifier we're using, this would be kinds of agent. Okay, see, this verifier you are using, right? This should be also kinds of agent. It will also have some kinds of large language model, okay, to understand this particular output. Now here there are different techniques you can use. Either you can use your custom agents, either you can use some kinds of tool here. Okay, I'm going to show you two approaches today. We'll be creating one agents with the help of our own custom agents with the help of large language model. Even I'm also going to show you an amazing tool called test sprite. Okay, with the help of test sprite also you can create this particular verifier. Do we have framework for the implementation of the loop, or it has to be custom function? See, this is just a custom things. Okay, you have to create this particular verifier whether whenever you are creating any kinds of agents. Okay, let's say we're creating a blog writing agents. So after generating the blog, just try to create another agents to verify that particular blog before publishing it. Getting Rajesh? So this is just custom things. You are writing that things. There is no direct framework you can integrate here. Okay, but there are some tools definitely you can use to create this particular verify. Okay, some more tools are available. One of the tools we'll be using called Sprite. Okay, I'm going to show you these tools as well, how to work with that tool. Okay, don't worry. So this particular verifier will verify this answer or this output. If it is good, it will return. Otherwise, it will give the feedback to the agents again. Based on the feedback, agents again it will work and it will generate another output. And again, verifier will check that. So that's how this loop will continuously run unless and until we are not getting our actual output. Okay, whichever we are expecting from the agents. This is what actually our goal. This loop should not be infinite loop. There should be some kinds of termination condition. Either you can terminate with the help of HITL, either you can give any kinds of maximum iteration, either you can, okay, either you can provide a different condition for that. Okay, so that's why you will see that in this loop agents, what will happen? First of all, it will generate an answer, evaluate that particular answer. If it fails, create the feedback, try again with the feedback, stop when this passes or reaches the limit. One thing you have to remember, important things, a loop must have stopping rules, otherwise the agents may keep spending tokens and time without reaching the better result. So that's why one termination condition is super important here. Okay, now we'll try to understand how this termination condition we can add. Okay, whenever we'll see the practical, I'll show you this part as well. Now see, this is what our actually this verifier, this is what our custom verifier, that means we're using some kinds of large language model, some kinds of agents here, right? But one more architecture I want to show you, you can create with the help of test sprite verifier. So let's say this is your agents, it is getting a goal, your agents is running. Okay, let's say it has generated a one website, or this website is live, okay, on the server, and you have used this test sprite verifier. Okay, test sprite is a tool. Okay, I'm going to tell you, it's a testing tool. It's a testing tool. You can test your applications. So this tool automatically checks your application is having any kinds of bugs or not. If it is found any kinds of bugs, okay, what will happen? It will generate some kinds of bug snapshot. Snapshot means it will understand the bugs, where it found the bug, what is the problem. It will automatically understand, okay, and it will generate a snapshot. Okay, this snapshot will go to the agents again. Now agents will understand, okay, so I have a problem in this particular section, in this particular line. This is the problem. Now it will again take this particular snapshot. It will improve the code. Again, it will make it live. Again, test sprite will check that. If now it is found completely good, it will send the pass and you will achieve your goal. Okay, otherwise this loop will continuously run. There would be some kinds of stopping condition. Okay, either you can stop, either you can set some kinds of maximum iteration from your end. Okay, now you can see the coding agents builds or change the app. Test sprite checks the live app. Test sprite says pass or fail. The agent uses the failure evidence to fix the issue. Test sprite returns the same verifications. So the loop is agent acts, test sprite verify, agent fixes, test sprite verify again. So this is what our loop is running here. Okay, kinds of you can say, but this is kinds of different purpose we'll be using. Okay, I'm going to do this part. Don't worry. Okay, stay with me. I'm going to clarify each and everything. Okay, now see, we'll try to understand this anatomy of a good loop. That means inside a good loop, what are the tools things should be available? Definitely the goal, observation, feedback, actions, evaluation, and most importantly, the stopping rule. Okay, without stopping rule, don't create any kinds of loop, guys. Okay, so simple formula, loop is equal to goal plus action plus evaluation feedback plus stopping conditions. If you combine all of them, you will be writing a good loop inside your agents. Now let's try to see the difference between non-loop agents and loop agents. Now non-loop agents answer once, okay, fast and simple, lower cost, no automatic self corrections, best for low risk task. Okay, but in on the other hand, loop agents can try multiple times, checks the output, uses feedback to improve, higher cost, best for multi-step task. Okay, so this is the difference between your non-loop agent and loop agents. Now we can decide which one you have to use based on your requirement. If your requirement is having a reliability more, that time you can use loop agents. If your problem statement is having some kinds of low level task, that time go with non-loop agents. Okay. It's completely up to you. Because if you're going with loop agents, definitely there would be higher cost because of the tokens. Okay. But if you're going with the non-loop agents, there would be lower cost because it generates the output only one shots. Okay, so here speed matters, here quality matters. So whenever you are worrying about the speed, you need a faster response. That time go with non-loop agents because it runs one time. But whenever you need quality, that time go with okay loop agents. Because if you are using these kinds of coding agents, you will see that here time doesn't matter. Okay, we can wait until our execution is over. We only wait for the quality of the output you are getting from the coding agent, right? So here time doesn't matter. So that's why they are using loop agents. But if you're worrying about the time, especially chat gpt, we need a faster response. That time we'll be using non-loop agents. I think we're getting, like I'm doing SF projects, I will manage that with prompt only, but for quality it's required. Yes. Okay, so one line you can tell, in non-loop agents answer once, a loop agents work, checks, improve and repeat. Yeah, we'll do the project. Okay, definitely I'll show you the practical. Don't worry. Okay, stay with me. I'll show you two practical. One practical will develop with the help of custom agents. We'll create a custom verification. Okay, verifier, and one agents will be creating. Okay, especially see this thing test sprite we use with the help of existing actually loop agent. That means our coding agents. Either you are using Copilot, Codex, okay, or let's say Cursor ID, we will be using test sprite. So I'm going to show you. I'm going to show you application level development. Even I'm also going to show you the existing agents we are using, how to integrate these things. Okay, this verifier. I'm going to show you. I will send you. Okay, everything. Don't worry. Okay. Now let's take an example of these coding agents. Uh, so sorry, let's try to take an example of this loop engineering. I'll take this coding agent example. So the agents write the code, runs tests, okay, read the error, fix the codes, and runs the test again. Okay, that means in coding agents, what happens? You are writing the code, your code is getting verified. If found the bugs, okay, again it will give the feedback. Again, your agents will write that. Then once it is fixed, you will get the output. Okay, so typical coding loop is issue, generate the code, run test, read errors, fix code, reset, final patch. Okay, stopping condition, all test pass, or the agent reaches the maximum number of repair attempts. Okay, so this is our termination condition here. Okay, now one example is travel planning. Let's say you want to build a very robust travel planner. It will generate a travel plan for you. First of all, it will checks the hotel, it will checks the different places, it will also checks the flight. Okay, so it needs a different verifications. Let's say if I'm using non-loop agents, so there is a possibility it will generate a dummy flight for you. Okay, let's say this flight doesn't exist, but if I'm using a verify, this verifier will verify whether this flight is exist or not. If exist, okay, what time, okay, what date, which airport, again it will verify everything, then it will give you the final responses. Okay, so as you can see, loop checks, is within the budget, are dates valid, is travel time realistic, are hotels available, does it follow user constraint. Okay, so these are the checks it will do in the loop itself. If it is matches, then you will be getting the final travel planning output. Otherwise, this loop will continuously run unless and until you are getting this particular response. Okay. Hmm. Hmm. Now let's do the final recap. As you can see in loop engineering, we'll do definitely the looping concept. So whatever things we have learned so far, the non-loop, okay, basically it answer once and stop, use for simple and low risk task, and loop, work, check, improve, and repeat until the result passes. Evaluator will evaluate the quality of the answer we are getting. You can even add the guardrails, okay, if you want. Let's say nowadays people are also integrating guardrails, safety, right? To prevent the violation, okay, or let's say any kinds of sexual content, or let's say any kinds of harmful content. Okay, so they're using guardrails to prevent that. You can either integrate guardrails. This is optional. Okay, If you're creating agentic AI application, I'll suggest you also use the guardrails here. Then definitely there would be a stopping conditions. That means your agent should not be infinite. Okay, infinite loop. There would be some kinds of stopping conditions. Hmm. Evaluation is a later step. I mean, after creating your agents, you can do the evaluations, but guardrails should be added. Okay, guardrails is important here. So that's why there is another PPT. You can see guardrails inside the loop. If you want, you can add a guardrails. Okay, guardrails means whether the content you are getting from the user, this is safe or not. Okay, this is safe to execute or not. So this is what actually you have to add inside the guardrails. Get it? Hmm. So yes, this is all about our loop engineering understanding, at least on the theoretical level. Now, tell me guys, are you clear? The entire concept I told you about this loop engineering. If you are clear, then I will go to the practical implementation right now. Guardrails, what is that? Let's say if user is giving one input. So let's say I'll take this example. Okay. Let's say you are using the coding agent. Okay. You are using a coding. Let's say you are using Cloud Desktop. Okay, or sorry, not you are using, let's say, Copilot, Microsoft Copilot. Okay. So now you're telling Microsoft Copilot to write a code to hack Google platform. Now tell me, will your Copilot will write that code for you? Just try it right now and tell me. Definitely you will see that it will tell, no, I can't help you with that. It doesn't meet with our guardrails, right? It doesn't meet with our policy. This is what your guardrails. That means if you're doing any kinds of illegal related task, if you're giving any kinds of illegal related prompt, which is having a violation, which is having, let's say, I mean, harmful related content. So these kinds of work, your agents will not work. Okay, this is called actually guardrails, the role of the guardrails. It's provide security on the AI generated things. Yes, exactly. Yeah. Okay. Hmm. Now I will go to the practical development. First of all, we'll try to develop this architecture. Okay. First of all, we'll work on this architecture. That means here we'll try to create a multi-agent system, and here we'll try to write a verification agents. Okay. So whatever answer, whatever result we'll be getting from our agents, first of all, we'll verify that. If this verification meets, then we'll continue. Otherwise, we'll give the feedback to the agents again. Okay. So for this example, I'm going to take one very simple example so that everyone can understand, because I know that in this webinar, there are different types of learners are available. Some of the learners are completely beginners. Some of the learners are intermediate. Some of the learners are advanced. Okay. So I have to take care everyone. So that's why I'll take a very simple example. We'll be creating a blog writing agents. Okay. We'll be creating a blog writing agents, multi-agent blog writing agents, and there we'll try to integrate this agentic loop. Okay. And even after that, I'm going to show you this application level verification as well. Let's say if you're using Microsoft VS Code, let's say, I think you use VS Code, right? Let's say this is our VS Code. So in VS Code, you have the agents as well, right? Here we give the prompt, and this Copilot will generate the code for me. So this is one kinds of coding agents. Then you will be using Cursor ID, Codex, right? To the code. So these are the coding agents. So how we can utilize testflight as a verifier in this kinds of existing agentic applications, we'll also try to see this example as well. Okay, both example I'll show you. First of all, this example, then this example. Okay, we'll try to see both example. Okay, fine. So for this, let's try to create a folder here. So I'm going to create a folder, and I'm going to name it as, let's say, mm, I'm going to name it as, let's say, loop agent. Okay, self-correcting agent, whatever name you can give, it's up to you. Here I'm going to open up my terminal. And I'm going to open up my Visual Code Studio here. Hmm. So I believe everyone is having VS Code Anaconda installed in your system. Yes or no? I'm expecting you have these are the tools, right? These are the things are common. I'm not going to repeat it again. Okay. Hmm. Hmm. Right. Okay. Now see guys, the agents I'm going to develop. First of all, let me show you the architecture. So this is the agents I'm going to develop. Save correcting multi-agent system with the help of loop engineering. So this is the architecture. So here user will give a questions. Okay. That means the block topic. And what will happen? This will go to the writing agents. Okay. Writing agents will write that. Okay. See, for the simpler purpose here, I'm not going to add any kinds of tools. You can integrate any kinds of tool if you want. You can integrate any internet search tool, which is Tably, Sarap API. Okay. You can use anything, but for the simpler purpose, I'm going to directly invoke the large language model to generate the content for us. Okay. Then what will happen? This writer agents will write something, and this is our verifier. Okay, these agents will be creating for the verification. That means whatever writer agent is writing, before I give this particular content to my let's say user, first of all I will try to give to the reviewer agents. Reviewer agents will try to review that. Okay, it will try to verify that whether this written content is good or not. Now definitely there should be some kinds of condition will add what kinds of let's say blog I want, what kinds of content I want from the writing agents. Let's say someone will prefer beginner friendly, more clear. It will also have the examples. Okay, so these are the, let's say, my rules. Okay, whenever I want to generate some kinds of content from my agents, I should have some kinds of rules. Let's say every time whatever content it is generating, it should have a beginner friendly, okay, beginner friendly discussion. It will also have some kinds of example. Okay, it will also have some kinds of, let's say, code example, any kinds of rules you can assign here. So my reviewer agents will try to review that whether it is meeting that particular criteria or not. If it is meeting the criteria, this will pass that. That means user will able to see the final answer. Okay, otherwise what will happen? It will send this particular, okay, it will send this particular feedback to the revisor agent again. Okay, either you can directly send to the writer again agent again, but you can also create a different agent for that, for the revision operation. That means whatever writer agent has done some mistake, you already captured inside this writer agents. Okay, sorry, reviewer agents. That means all of the feedback. Now this feedback you are giving to the another agents called revisor agent. Okay, revisor agent will try to revise that. That means whatever content I generated, again I'll try to improve that. Okay, based on the feedback. After improving that, I'll try to send to the reviewer. Okay, reviewer will again try to review. Again, it will check whether these particular things are perfect or not. If perfect, it will give you the final answer. Otherwise, again, it will give the feedback to the revisor agents. That means this is the loop we are creating here. I think you can see this is the loop, guys, here. Okay. Now, instead of revisor agent, you can directly also pass to the writer agents. But here, I'm going to create a revisor agent. Okay. This is completely your design philosophy. Okay. You can either keep only one agent, either you can keep multiple agents. You are designing your own agents. Okay, so the way I'm creating, it's not necessary to create it. Okay, you can also change this architecture as per your requirement. Okay, so here what is the stop condition? Reviewer get it passed. That means once it is passed, either maximum revision limits. Okay, we'll try to add the iteration limits. Let's say after 5 iteration, if we are not able to get the output, whatever final output we got, we'll try to show as a final answer. Okay, so this is what our stop condition is here. So are you clear, guys, with this architecture? Yes or no? Tell me. Clear? This architecture you are getting, the loop condition you are getting. Now let's try to implement with the help of LangGraph. Okay, I'll be using LangGraph framework to implement this particular agents. Now, how many of you are familiar with LangGraph here, guys? Tell me. LangGraph is a agentic AI orchestration framework. Okay, with the help of LangGraph, we create agentic AI applications. Okay, if you are not familiar, guys, I think on Krishnaik Academy there are different courses, different tutorials are available on the Langgraph. You can go ahead with that. Okay, I think it will help you a lot to understand. Again, I'm going to explain in a simpler manner. I think you will try to understand. Fine. So let's try to use LangGraph to implement this self-correcting multi-agent system. Okay. So for this, I'm going to open up my VS Code, and here, first of all, I'm going to do the project setup. Okay. So first of all, here I'm going to write a README file. Here I'm going to show you all the commands you need to execute. First of all, you have to create the environment. Okay. So conda create. You can also use UV, but I'm going to use conda. Conda create -n. You can give the environment name. Let's say I'll give agent. Okay. Agent test or anything you can give. Then you can take the Python. Let's say Python is equal to 3.11. Okay. Or you can also take it as a demo. Okay. It's up to you. Any kinds of name you can take from here and you can give the yes permission. So this is what you have to execute to create the environment for you. Now I'll copy this okay command and execute from your terminal. Okay, so I already have this environment, guys. I'm not going to create, but if you don't have, you have to create this environment. Okay, so after creating that, you have to activate this environment. So for this, you have to write this command conda activate, okay, demo. So conda activate demo. So see, this is our environment I already created. Okay, but if you don't have, please try to create. Okay, after creating it, you have to install the requirements. So let's write pip install -r requirement. Okay, requirements.txt. Okay, so we'll be creating a requirement.txt file here, and said that I'm going to mention all of this requirement I need. Yeah, you can also use UV. Okay, there is no issue. Any kinds of package manager you can use. Now here I need some of the package, guys. So here I'll be using, these are the package: LangGraph, LangChain. I'll be using Grok provider, guys, to access the large language model, because I know that many people doesn't have the OpenAI API key. That's why I'll be using free model. Okay, Python.env to manage the environment variable. That means here we'll try to mention all of the API key and everything. Agentic for the structured output. Fast API will be also creating a simple user interface and backend API with the help of Fast API. Uvicon is the dependency package of Fast API, and Ginger 2 also dependency package of Fast API. Okay. Now simply you just need to copy this command and execute from the terminal. Okay, it will install all of the necessary package in your environment. So for me, it is already telling it's satisfied. Okay, one thing you will be doing, which is you have to take the version of the package. Okay, otherwise, if you're running this project after let's say 1 month, there is a possibility this project should not be run, because there should be some kinds of dependency change. That's why always you have to track the version. So for this, you can write pip list and you can check the version. Okay, so these are the version. Just try to take one by one and add it here. Don't do pip freeze operation, because pip freeze actually saves all of this package, but I don't want that. I will only want to add the version I'm using here, add the package I'm using here. Let's say LangGraph. Okay, so for LangGraph, I'm using this version. So I'll copy this version and add it here. Now find for LangChain. For LangChain, I'm using this version. Copy that, add it here. So this looks like more clean. Okay, I like this approach. Okay, then LangChain Grok. LangChain Grok, LangChain Grok. I'll copy this and add it here. Okay, I think I have done some mistake. LangChain Grok 1.1.3. Copy that and add it here. Now python.env. Python.env, this one. Yeah, pip list. Then pydentic. Fast API. Then Uvicon. And last we have Ginger 2. Okay. Yeah, so I have captured all of the version. Okay, now this is more clear enough. Okay, instead of pip freezing, I only have mentioned those are the packets actually I'm using here. Langchain var is not copied properly. Langchain, okay, let me check. Langchain. Okay, a good observation. I'll copy this and mention it here. Okay, now I think it looks good, right? Yeah. So now you just keep it this requirement with you. So if you're running this project after 1 year also, there should not be any kinds of problem because you have already captured the version. Okay, fine. Now next thing, guys, I have to collect the API key. So here I need some API key, guys. I need actually these are the informations. Yeah. First of all, you need Grok API key. So here we'll be using Grok provider. You can use any kinds of provider. You can use Gemini, OpenAI, OpenRouter, anything you can use, but I'm going to use Grok API here. And Grok model wise, I'm going to use Llama 3.3 7 billion versatile model and max revisions. Okay. Now, can anybody tell me what is this max revision parameter? I think you can see the architecture. This stop condition, maximum revision, that means limit. Let's say if my reviewer let's say if my writer agents or let's say revision agents is not able to write the content properly, okay, after two revision, that means two iteration, okay, it will stop the condition. Sorry, it will stop the loop because I have added the maximum revision here. Okay, but in real world, this maximum iteration should be a little bit bigger. But for example, I have only taken two here. Okay, after two iteration, it will stop. But in real world, you have to take a little bit more iteration here, at least 20, 30, 40, 50. Okay, you have to take this kinds of iteration. Okay, this is our safer purpose for the safer purpose. But there's a possibility our revisor agents will revise based on the feedback and it will generate something good for good for the user, and this particular check would be pass. Okay, we're expecting, but in case if it is failing, that time it will depend upon the maximum revision stopping condition that time. Okay, so these are the informations we have put inside my .env. Now let's collect this Grok API key. Now how to collect the Grok API key, guys? Very simple. You have to go to the Grok platform, Grok API key, search for Grok API key, go to the first website and make sure you create one account. You already have the account, guys. Here you have to create an API key. Okay, so I already have created this API key, and if you don't have, you just create it here. Okay, so I already have the API key. I'm not going to create again. Okay, but don't use my API key, guys. I'm going to remove after this session only. Okay, and here I'm using this model. Now how you can get the model? Go to the playground, expand it here. Now you are having different models. Which model you like, just try to select here. Let's say I'm using this model. I just copied this ID and pasted it here. Okay, get it, guys? Yeah. Now I'll be creating some more folder. I will be creating, first of all, I'll be creating a file called backend.py and app.py. Okay, then I'll be also creating user interface. We'll be using fast API. For this, I need templates folder. I also need static folder. How many you know about this one, fast API, guys? If you know fast API, I think you know that whatever I'm writing, right? Static templates, you know that. So inside templates, we keep our HTML code, index.html. This is the page. And static, we keep our CSS design and JavaScript. Style.css and app.js. And again, if you don't know about front-end development, guys, don't worry. You can take the help from ChatGPT and you can create this user interface. Okay. But in company, there are different job role for that front-end developer. They will basically take care part this part for you. Okay. So here I will be creating a very simple user interface. Even I have also taken the help from ChatGPT to create this user interface. Okay. HTML, CSS code. If you don't know, it's completely fine. Yeah. Hmm. Now, first of all, let's write our backend file because this should be my main agentic workflow. Okay. Okay. So first of all, here we'll try to import all of the necessary library. So these are the necessary libraries, guys. I need just a minute. Yeah, I need operating system. I need literal type dict .env, chat grok from langchain grok. Then from langgraph, I'm importing and start and state graph. Okay. So definitely you should have knowledge on langgraph. Otherwise, this session might be a little bit confusing to you. That's why I strongly recommend after this session, please try to complete the langgraph at least, like how langgraph works. Okay. What is the syntax? Just try to study about. Okay. Now from Pydantic, I'm also importing base model and field. These are the things are required. GitHub repo, I'm going to create. Okay. First of all, let me complete the implementation. After that, I'm going to share you the source code. Okay. Don't worry about that, Hitesh. Okay. I'm going to share each and everything. But first of all, just try to be with me and try to learn everything. Okay. Now I'll load my environment variable. So this is my environment variable. I'm loading it. Okay. After that, we'll try to load my model as well as the maximum revision from my environment variable. So this is the syntax for that. os.getEnv, I'm loading my grok model and I'm also loading my maximum iterations. Okay, even I'm also giving the default value in case, let's say you haven't mentioned these are the variable values here. So it will use that default one. Okay, at that time. Now we'll try to define a model. So here we'll be using this grok provider. We are giving the model ID, temperature, and API key. Whatever API key we're loading. Okay, API key, I think so we are loading it here. Wes.getEnv. Okay. We are loading the API key here as well. Get it? Now, those who already know about LangGraph, right? In LangGraph, the first thing we have to create, which is state. Okay. State means, let's say, I'll go to the architecture. Yeah. Yeah, I'll share this code after the implementation. Okay. First of all, try to see the implementation. After the implementation, I'm going to share this code with you. Don't worry. So see, every nodes will return some kinds of output. Okay. To save this output, I need a state here. In LangGraph, we call it as a state memory. Okay. So here we'll try to prepare the state right now. So these are the state I need. First of all, I need a topic, draft, feedback, decision, revision. Okay. Let me explain what I have written here. See, topic. Topic means whatever topic user will provide. Let's say user has provided agentic AI. Okay, this is the topic. Based on that, our writer agents will write something, right? So this topic information will save in this particular topic state and the type should be string type. Now we have draft. Okay, draft means whatever my writer agents will write on top of the agentic AI, this is called draft. So this draft result will try to save inside the draft variable, draft state memory. Again, the type should be string. Now the feedback. Okay, feedback means my reviewer will generate some kinds of feedback whether this particular written is good or bad. This feedback will try to save where inside the feedback variable. Again, the type should be string. Okay. Now decision. Okay, decision means our reviewer agents will also give me some kinds of decision. Okay, decision means whether this particular written should be pass or revise. If it is pass, that means your user will getting the final response. If it is revised, that means it will go to the revise agent again. So this is called decision. So this is decision, pass or fail will try to save inside the decision variable. Again, this should be string. Okay. Now the revision count. Revision count means how many times this loop is running. This information will save where in the revision count, because here I have to save the maximum revision. Okay, I think you have already saw that. Maximum revision I have added 2. That means how many times my loop is running, this information should be saved inside my revision count, and this should be integer type. Clear, guys? This state definition is clear, all of you. This is called state memory in LangGraph. You can increase the temperature parameter. It's the creativity parameter. You can either keep it to 0, either keep it to 1. It's up to you. But I have kept to 0 only. I don't want my, let's say, agent to more creative. Okay, I want like the authentic output. That's why I've given that. Yeah, clear, guys. The state definition is clear, and definitely, if you have a little bit of knowledge on the line graph, this code would be completely, I mean, easy for you. But if you are completely first to the line graph, it might be a little bit confusing. But I strongly recommend try to land the line graph. Okay, yeah, because LangGraph is the most demandable orchestration framework nowadays in the market. So try to master the LangGraph as soon as possible. Okay, if you want to be a Agentic AI engineer. So fine, guys, we have already created all of the state, all the utility variable we have created. Now we'll try to work on the agent. Okay. Now the first agent, guys, will try to create the writer agent. Type we need to let's say define the state here. See here. Okay, type dict means this is a dictionary type we have defined. This is the key, this is the value, this is the key, this is the value. So whenever it will save the information in the memory, it will save as a dictionary. That's why the type is dictionary. Okay, we call it as a type dict. And this type dict we have already imported from typing and we have inherited in this inside this particular class. Get it? This is a Python concept. And to define the state, we're using state function. No, you can get this state class as per your requirement. You can give any kinds of name, but I have given state here. Now we'll try to create this writer agent. Okay, let's try to quickly create this writer agent. So I already created our writer agent, guys. Let me just show you. These things are very simple. I'm not going to create from scratch. See, this is our writer agent. So writer agent is taking this state, okay, as an input. And here in the writer agent, guys, we are directly invoking the model. Okay, which model? The model we have defined here. Okay. Now here we are giving a prompt. Role content. You are a beginner friendly teacher. Explain the topic in, let's say, 120 or 160 words. Okay. So basically we're generating a topic. Okay. Topic or blog, whatever you can say. We are generating a topic. And this is our condition. Just try to generate a beginner friendly, okay, blog for that or content for that. Use a simple language, one everyday analogy and one tiny examples. Okay. And whatever user topic is giving, okay, so just try to take the topic from the state because inside the state we have the topic. That's why from the state we're taking the topic because this is a dictionary type right now. Okay. Now based on the topic, it will generate a content for that particular topic and it will return the draft result. Now this draft we are saving inside the draft variable. Okay. And apart from that, whatever things we have like feedback, decision, revision, we're making it as a completely empty because at the very first time we don't have feedback, decision and revision count. Okay. These are the things are empty. Okay. This is our writer agent is. Great. That means this writer agent we have created. Now we'll try to create our reviewer agent. Okay. Now we'll try to create this verifier, guys. This verifier. Again, this verifier should be one kinds of agent. Custom agent. Okay. Now see here, this is my verifier. Very simple. This is not a very complex topic, guys. The agents you are creating the same agents only you just need to make it as a verifier. In the prompt itself, you can tell you have to verify this particular result. Okay. Now to verify it, guys, I'm going to use another model, but in a structured way. Have you studied about Pydantic? Anyone here? Pydantic? I think you know with the help of Pydantic, we can generate a structured output. So this is what, yeah, we have generated. We have written a Pydantic class, guys. As you can see, we have inherited with the base model of Pydantic. And here we are telling the generated output should be decision and feedback. Okay, we are telling our model to strictly generate only decision and feedback. Decision means pass or revise, and feedback means what feedback you want to give to the revise agent. Okay, so this is what I need from the this agent. Okay, this agent, and to generate the structured output, I need this particular Pydantic class. Okay, but if you're not using this Pydantic class, every time your large language model will generate something new format. But I don't want that. If you want your agents or LLM format should be same, that time you can use Pydantic class for that. Okay, this is called Pydantic structure or data verifications. Okay, now this thing will be using, guys. This thing we'll try to use, but before that, we'll try to create an object for that. So this is the object we have created. Yeah. So reviewer model is equal to model with structured output, and we are giving this Pydantic class. Now, this object will be using here. Now you can see we're using here for the invoke operation. Now whatever prompt you will give to this particular model, it will only give you two things. One is the decision, one is the feedback. Get it? Decision means pass or fail, and feedback means whatever feedback it will provide to the revise agent. This is our your reviewer agents. Okay, now inside reviewer agents, you can see I have strictly mentioned you are the strict reviewer. Check the answer using only these rules. If it is easy for the beginner, it contains everyday analogy. It contains a tiny concrete example. It says focus on the requested topic. If any fails, okay, choose revise and give one or two practice improvement. Okay, so here I'm directly mentioned to the reviewer, you will strictly review or verify. Okay, your task is to verify whatever a writer agent is giving you. Okay, so whatever draft you are getting from the writer agents, just try to review that and give your own feedback. Okay, whether this should be pass or fail, and what is your feedback on that. Getting, guys? This is our verifier is. Okay, this is our verifier is. Got it? So this verifier we have created right now. This verifier. Clear? Now I think this part is clear all of you. See, this verifier, you can create anything. You can create either a custom agent, either you can simply use a large language model, but I will suggest you to use a agent here. That would be good for you. See, again, this be out Pydantic to understand, you should have knowledge on Pydantic, okay? Because in single session, I can't cover each and everything. I'm expecting you know about Pydantic, LangGraph. Okay, these are the things I think you should know at least. So after this session, please try to check one tutorial, small tutorial about Pydantic. I don't think you will have any kinds of questions, okay? Yeah, so Pydantic we use for the structured output to get from the LLM. Okay. Now my reviewer agent is done. That means my verifier is done. So here, let me comment. This is my verifier. This is my verifier in the loop. Okay. Now we'll try to create this agent, which is nothing but reviser agent. That means whatever review feedback it will get, based on that, it will do the improvement of the content. Okay. Now let's try to create this agent. So this is my reviser agent, guys. As you can see. So here we are again invoking the model, and we're telling you as reviser, improve the answer using the reviewer feedback. That means whatever feedback we are getting from the reviewer, just try to use the feedback and improve that. Keep it beginner friendly and concise, return only improved answer. Okay. So whatever topics and draft we got and whatever feedback we got, based on that, it will do the improvement. After doing the improvement, okay, it will again save the content to the draft. Get it? And that means this part is also done. Okay. Now what is left? Left is nothing but the connection. Okay. Now we have to connect all of the agents together. This is called connection in LangGraph. Okay. Now we'll try to connect everything. We'll create graph. We'll add the nodes and connect the edges. Okay. But before that, I need to create another function. So this function will basically route your direction. That means if your reviewer agent is giving pass, that means it will directly end that particular workflow. That means user will get the final answer. But if it is written revise, that time revise agent will be triggered. Okay. So this is what we are writing. If our decision is pass, that time return done. Otherwise, okay, just try to check the maximum revision. Okay. And try the loop. Okay. And what to return? Return revise. That means it will go to the revise again. Okay, and revise will continuously generate and improve that particular content. Okay, once this iteration is done, just try to break this loop and return done. Okay, this is one simple condition we have written. Now we have to add inside the graph, LangGraph graph. Okay, now how to add this LangGraph graph? This is what we usually write. Okay, so state graph, we are using this function state graph. Inside that, we are giving the state and we're adding the nodes. First of all, we are adding the writer agent, then reviewer agent, reviewer agents. Okay. Then we're adding the reviser agent. These are my agents. Okay. These are my node. After that, we're doing the connection start to writer. So start to writer, writer to reviewer, writer to reviewer, then conditional edges. That means if reviewer returns, if reviewer returns done, it will directly end the workflow. Otherwise, if it is return revise, it will go to the revise agent again. So this additional conditional edges, right? Basically, this changes the direction. That means this direction. This is the loop. If it is returns, it will directly end. Otherwise, it will go to the revise agents and this loop will run. So this is what we are doing here. Okay. Then at the last, we are adding reviser to reviewer. Reviser to reviewer. That means it will again send for the review operations. Okay. So this is our simple graph definitions. Okay. Inside line graph. And we are compiling the graph at the very last. Okay. After that, we'll try to run this workflow. So to run this workflow, we'll be using one function for that. So this is the function we'll be using. Okay. This is a very simple function we are using. Run the workflow. So here what we are doing, we are first of all generating all of the state, topics, draft, feedback, decision, revision count. Now see, at the very first time, only topic would be there. These are the things would be completely empty. At the very first time, whenever you are executing your agents, there should not be any draft, feedback, decision. Okay. So that's why these are the empty. So every time, whenever it will run, this are the variable should be added that time. Okay. Only at the very first time, topic should be there because we are getting the topic from the user. Then what we are doing, we are executing the graph. Okay. This graph, whatever we have, we are executing the graph and we are giving the input and whatever output we are getting, we are returning it. That's it. Okay. Now let's try to test whether it's working or not. Now to test that, simply what you can do, either you can also test in your terminal. In terminal demo, let me show you. I created another function for this terminal. So this is the function you can use to check your agents in the terminal. So we are invoking this run workflows, okay, and with the topics, and we are running it. Okay. Now let me show you how this works. So for this, I'm going to open up my terminal and clear it. Python backend.py. Now it is asking for the topic. Let's say I will give Agentic AI. Enter. Now see guys, it has configured the model, everything. Writer agent has written something. Reviewer agent decision is passed. Okay, they see first writer whatever it has written at the very first loop, my reviewer agent selected that. That means this particular content is good. It is easy to understand. It has the example. Okay, whatever constraint we have given in the reviewer, it is checking everything and it is making it as a pass. Feedback, no change needed. And this is what our final answer. Okay. But if you are giving any complex topic, agentic AI in advanced, let's say advanced way. Now see guys, here multiple revision required. So this is the first written. This is the reviewer. Reviewer, it is see, decision is revised. Now this particular generation it has done. This is not beginner friendly. That means this condition is not matching right now. This condition it's not matching. Okay. That's why it is giving the suggestion again. Okay. It is giving the suggestion. The answer provides a good analogy and example, but it could be improved by adding more focus on the advance. Okay. That means whatever user wants. Okay. Based on that, it is giving a feedback. Again, reviser is generating something. Okay. Again, reviewer is checking. Now it is got passed. Okay. No change is needed. And this is the final answer. Get it? Now you can see revision used one. That means one revision required. That means one iteration happened inside my loop. It is yes or no? Tell me. Yes or no? Are you clear? This looping concept, how it is working. Now this is more reliable output. Okay. This is not a single shot generator. This is using some kinds of verifier. After verification, it is giving me the final answer. Although token is getting more cost here, but yeah, we are getting some reliable output. Now this thing I have executed in the terminal. This not looks good. Now we'll try to add a user interface. Okay, simple user interface so that you can use it from the user interface. So for this, in the app.py, we'll just write the fast API code, guys. Again, don't worry if you don't about the fast API, if you don't know about the HTML, CSS, it's completely fine. You can generate this code from ChatGPT. Okay. So only you just need to import fast API. So these are the libraries are required from fast API. And we also need to import this function run workflow, because this is our final function. Okay. Inside app.py. So I'll just write from backend import run workflow. Okay. After that, we'll try to initialize the fast API. So that's how we initialize the fast API, and make sure you write all of the HTML content and CSS, everything. Again, don't worry about the HTML, CSS. You can easily generate it from ChatGPT. Okay. I also generated from ChatGPT. These are the things. Now I'll add the CSS design. That means the color, ingredient, okay, everything in the CSS, and some JavaScript code to work with my API. Yeah, so these are my JavaScript code I generated from ChatGPT. Okay. Now simply I'll just add my remaining code. This is the simple fast API route I created. Let me show you. So this is the simple fast API route. So this is my home route. That means if user hits my application, user will able to see the index.html page. Okay. And if user hits the API/run, it will execute my function, run workflow functions. Okay. And we are running on localhost um, port number 8000. And this is running in app.py. So here also I have to provide app. Sorry. App. Okay. App is to app, because here I have created the app object. Simply you can copy this backend code. Okay. You can copy this backend code and you can give the you can give to ChatGPT to generate a user interface for this particular project. Okay. ChatGPT will automatically understand what kinds of user interface it needs. It will give you these kinds of CSS, HTML design. Simple. Okay. Now let's run and try to check whether everything is fine or not. So I'll open up my terminal, clear, run the Python app.py. Now this application is running localhost port number 8000. I'll go to my Google, search for localhost port number 8000. Now see, that's how my application looks like. Is it good, guys? The interface is good. So again, I generated from ChatGPT, but I think it looks good. Okay. Yeah. Now simply here I have writer agent, reviewer agent, reviser agent. Okay. Now let's give a topic. Let's say I'll give what is agentic AI. Now, if I run this loop, you'll see that writer agent has written something, reviewer agent has reviewed, and it got passed, because the first iteration, the content it has generated, it looks good. Okay. And this is our final response. But now let's try to give another one. Let's say what is agentic AI in advance. Add advance. Wait. Now if I run this loop, now it should do multiple iterations. See, first of all, writer agent has written something, reviewer has reviewed that, and it got revised. Okay. It is telling the answer is not easy for the beginner. Okay. Again, you have to generate something. It has generated. Again, it got reviewed. Okay. Then again, it saw that this answer is not good. Again, it needs some revision. Again, it generated some feedback. Again, reviser agent will generate something. Again, it will review. Okay. Now see how many iteration it has done. Just try to check. Revision 1, revision 2. What was my maximum iteration? What was my maximum iteration? Tell me. 2. That means 2 maximum iteration is over. That time, whatever final answer I got, this should be my final result. Okay. But if you increase it to a little bit more, let's say I'll give 5. Now let's try to see what happens. I'll give this prompt again. Now see, First time, second time. Yeah, second time it got approved only. Okay, so this is what we give for the safest purpose. If in case my loop is not breaking, it will break as per the maximum iteration. Otherwise, if it is matching with the reviewer rules, that time this particular loop should be break. Clear, guys? Yes or no? Tell me. I think in the user interface it is more clear. So how was this project? How was this example of this on this loop engineering? Did you like it? Are you able to understand? Yeah, I kept everything simple so that everyone can understand. Thank you, guys. Thank you. Perfect. And all of the source code, I'm going to share each and everything. No need to worry. I'm going to share you each and everything you can execute from your end. Yeah, loop engineering only consists of self-correction aspect. Yeah, Shoel Sharma, you are right. Because if it is not doing the self-improvement, then how it will generate the perfect result for you? Okay, that's why self-improvement is required. So in everyone live also, this loop engineering concept should be included. Okay, everyone live. So if I'm running my own live, I should have this loop. That means the verifier. Okay, so that whatever work I'm doing, I need some kinds of feedback so that I can improve myself daily basis. No, I haven't created a GitHub link, but I'll create a GitHub link. Just give me a minute, and I'm going to share you the source code. Let's create one GitHub link, guys. Repository. So this is my GitHub. You can search with the name ENT Bappi. So you can create a new repo. I'll give what I can give. Self-correcting multi-agent system. That's this name I'll give. Now I'll keep it as public. Add README file. I think I already have the README file, not required. Git ignore, I'll add Python. Using Python and license. Let's take any license. I'll take Apache one and create the repository. And one thing you can do, you can write the README in a good way. So you can ask your agent to do that. Update the README file for this project like an open source repo. So it will automatically understand my code. Based on that, it will write the README file for me. Because README should be properly written. Otherwise, nobody can understand your project. Okay. Yeah. See, this is what our coding agents. Now see, one prompt I have given. It is also using the agentic loop concept in the backend. Now I'm going to show this example as well. Okay, how to utilize these kinds of coding agents and add a verification layer there. Yeah, so it is writing the README right now. It is understanding my project and writing the README for me. I can also write, but it will take time. Okay, line by line, I have to write everything. I don't want that because AI is everywhere. Now see, README has written completely properly. See, even I can show you the preview. Now see, now this README is more readable. Okay. Now let's try to commit the changes. I'll click on code, copy the link address. I'll open up my terminal, stop the execution. I'll just write git clone, paste the URL, clone it, and inside that, whatever I have, okay, I have to also enable the hidden items. Okay, now I can see the git folder. Let's copy everything and paste it inside my project directory, and I'll delete this folder. Okay, I have opened it in a what I can do, I can simply close this file and now let's delete it. Okay, now done. Now I'll open my VS Code again. Code space dot. Okay, now let's commit the changes. Clear. So git add space dot, then git commit hyphen m updated code, then git push origin main. So it has pushed. Now I'll go to my GitHub and to refresh. Now see, my repo is updated. Okay. Now I'm going to share you the URL. Everyone, I'm going to share you the URL. Now tell me guys, are you able to access my GitHub? Are you able to open the GitHub? Okay. Now keep the code and please try to execute in your system as well. Okay. And if you found any issue, do let me know. Okay. Perfect. Now what I will do guys, I'll simply go to show you the next example, which is this architecture. Okay. Now I'm going to use existing um, agentic um, agentic application. That means we'll be using coding agent. See, I'll be using the VS Code agent only. You can use also cursor ID, then codex, anything you can use, but VS Code comes up with by default is okay, Copilot. So I'm going to utilize the Copilot, and we'll try to see how we can use test sprite. Okay, test sprite as a verifier to run the tests and find the bugs and how we can fix it automatically. Everything we'll try to see that. Perfect. So let's start with this second example. That means test sprite as a verifier. Now, first of all, let me tell you what is test sprite exactly. So you can search for test sprite, okay, .com. So this is their platform. So this is agentic testing for AI native teams. Okay, that means you can test your AI agents. That means you can use it for the verifier. Okay. Now they're having two kinds of like product. One is the MCP server. You can directly use MCP server. Either you can use test sprite CLI. Okay, test sprite CLI. So this is the product we'll be using. Okay, we'll be executing everything from the command line. Okay, so this is the CLI. So as you can see, test sprite, this is the verification layer for the agentic AI, agentic coding era. That means if you're using any kinds of coding agents, that time you can use this test sprite as a verifier. Okay, that means the verifier I told you, this verifier, this verifier. That means whatever your agents is generating, definitely there is a possibility there should be some kinds of mistake, okay, in the code. See, you are using coding agents, it's completely fine. But after using coding agent also, there is a possibility there should be some kinds of bugs. Your application is not working the way you were expecting. That's why you can use test sprite as a verification layer. So whatever coding agents is writing, definitely test sprite needs the live application. Okay, so you first of all need to deploy this application. Okay, and after that you have to give this deployment URL to the test sprite verifier. Now test sprite verifier will go to the deployment server. It will check the application. So I think you know, right? Previously we had to had tester inside company. Have you seen that? You will get these resources inside this platform only. Okay, even I have already shared you my GitHub URL. So this is the GitHub. Inside that you will get all of the resources. Okay. Test sprite is a production grade. Okay, it's a production grade platform. Okay. So have you seen previously all of the company used to hire tester, software tester or AI tester guys. Have you seen? So what is the work of a tester? Tester means they will test the applications, okay, and they will find the bugs. So Sprite you can use as a tester inside your application. So basically, it will test the application. If it finds any kinds of bugs, it will generate the failure bundles. Okay, failure bundles mean it is a snapshot. That means what it has the issue, what line it has the issue, what is the issue. It will give you the complete evidence. Okay, this evidence will try to send to the coding agents again. Coding agents will try to read that. Again, it will fix the code. Again, will deploy. Again, will try to run the test sprite. Test sprite will verify the server. Again, it will try to find the bugs. If bug not found, then it will pass that. Otherwise, again, it will generate the failure bundle. Again, it will try to send to the AI coding agents. Okay. So this is the loop actually we have to create right now. Now we'll be using this sprite verifier as a, sorry, test sprite as a verifier. Now this is the test sprite CLI we'll be using for that. Okay. Now you can see it. What is test sprite CLI? So test sprite is a AI testing platform. Uh, they have that many of teams to use their software, front end and back end, both you can test in the cloud against the live product, not mocks the repo. It's official CLI. Okay. Now they have already given their quick start guide, like how to use that, how to install that, everything they have given. For this, definitely you need Node.js install in your system, which is very easy. Simply you can copy this and you can search over Google Node.js install or download. And as per your operating system, just try to download and install. Okay, those are using Windows, use the MSI downloader. If you're using any other operating system, you can check your operating system and you can also execute. Okay, so for me, I have already installed Node.js. Okay, the first step, guys, you have to install the Node.js. Okay, after installing Node.js, guys, you have to install this test CLL. Okay, so I'm going to show you step by step everything. First of all, let me show you the application. So see what I've done, guys. I already created one application. Okay, with the help of my coding agent. Let me show you this application. So this is the application I created. Now let me show you first of all this application, how this looks like. Now again, this application I created with the help of Node.js. Okay, Node.js. This is the web application I created. Let me show you. Now you can use any application, not Node.js application. You can use Python application, any kinds of agent application. It's up to you. This step you have to see how we can use this test as a verifier. Okay. Now I'll open up my code. Let me zoom. Yeah. So what I've done, guys, see, I have opened VS Code and I told VS Code create a loop cut application. Do you know what is loop cut application? I think those who have already used any e-commerce site, any purchasing website, you will see that you will select a product. After that, you will do the checklist, right? And if you are having a coupon code, you can provide the coupon code, you can get the discount. Have you seen this kinds of application, guys? I think every platform is having this kinds of functionality. Even course purchase also. Whenever you want to purchase the course, you will have a coupon code, right? If you give the coupon code, let's say save 20%, you will get 20% offer and you will get the final amount. Okay, this kinds of application I created here. Let me show you. I'll first of all run this application and let me show you. So to run this application, guys, I already given the command in the README file. So in the README, everything is available. I'll make it as preview. So you have to run this command. Okay, but before that, you have to install Node.js, guys. Okay, the way I showed you. So let's copy this command and execute from my terminal. Now this application is running localhost port number 5173. So this is the application. This is the application, guys. Look at checkout. So let's say I have purchased one mechanical keyboard and agentic engineering book. Let's say this is $60. This is for $40. How much dollar? $100. Okay. Let's say I have a coupon code. The coupon code is save. This is the coupon code. I'll copy and paste it here. Now see, if I apply coupon, that means how much percentage it should return me, guys. Tell me. If I apply this coupon, so what would be the total price as per your knowledge? 80, right? But see, what I have done, I have added a bug in this application. Let me show you. If I apply this coupon code, it will show you 2 discount only. Is it correct? It should give me $20 discount. It is giving $2 discount. Is it correct? Let me know. No, it's not correct, right? That means total amount I have to pay $98. That means definitely this application is working fine, but there is a bug. So this kinds of mistake your coding agent can do because it's not a human, right? Again, it's an AI. So there is a possibility whatever whatever code you are generating from the coding agent, whether you are using Copilot, whether you're using Codex, whether you're using Cursor ID, it doesn't matter. There is a possibility there should be kinds of bug. Okay. And this bug we have to figure out. We have to test this bug. Now, either you can test it manually, either you can use some kinds of, okay, and the tool will be using TestSprite CLI for that. TestSprite CLI, what it will do, it will automatically figure out the bugs from the application. It will generate the evidence. This evidence it will send it to the agents. Agents will try to fix that. Again, it will run the test, and again it will check whether this bug is available or not. How many times it will run unless and until this application got fixed. Okay. Now we'll try to see this application. We'll try to check this application with the help of TestSprite as a verifier. Okay. Hmm. Just a minute. All right. So now what I will do, guys? So it's like a coding agent to TestSprite and feedback and fix. Yeah. See, TestSprite, it's a tool. Okay. And you are using whatever coding agent, it's completely fine. So you can use TestSprite as a verifier so that whatever coding agent is generated, let's say I generated this project with the help of this Copilot. In the VS Code Copilot I have, right? I given a prompt, I need this kinds of website, please generate for me. So it has given me this website. Now, when I executed this website, I saw it's working fine. Only mistake I saw that this is giving me $98, although it should give me $80. So this is a bugs, right? Now, either I can like fix it. Okay, I can fix it manually. Either I can ask my agent to do that, but there is a possibility this error is like very major error. Let's say there are thousands code you have written, very big application you have created. That time it's would be a little bit difficult for you to find the right bugs. That time we can use TestSprite as a verifier. So what I will do, I'll use TestSprite and I'll tell TestSprite to verify this project, test this project. TestSprite will run all the test cases and it will figure out the bugs if it having any kinds of bug. And these bugs, it will show me as evidence. Okay, I will be able to see the bugs in live demo only. I will be able to see. I'll show you. Okay? And this live evidence, I will again provide to my agent that I got this bug. My TestSprite found these bugs. Now try to fix that. Then my agents will again fix that. Then we'll try to correct this application. That's how the things works. Get it? How it will know the test cases. TestSprite already having all of the functionality. That's how TestSprite has been designed. Okay, this is the work of the TestSprite. It will run all of the test cases, and how it will run the test cases, everything they have created in the TestSprite CLI itself. We don't need to worry about that. We will be only executing few commands. That's it. Okay. Yeah. First of all, let me show you the demo. That time you will understand. Okay. Now see, this application is running completely fine. There is no error. Sorry, error definitely when bugs is there. Now, first of all, see, TestSprite doesn't work locally. It has to be remote server. So first of all, we'll be deploying this application over the Vercel website. Okay, Vercel cloud. So make sure you create one account in Vercel, guys. Okay, free account you create. Vercel also you can deploy your application as free. You just need to create one Vercel account. Okay. So this is my account. I already logged in. Now we'll try to deploy this application. How we'll deploy this application? We'll try to open the terminal, stop the application, and few commands you have to execute. So first of all, you have to execute this command. First of all, you have to install Vercel. So this is the command for that. npm install -g Vercel. Now you can deploy anywhere. You can deploy AWS, you can deploy render, anywhere you can deploy. This is the Node.js application. That's why I'm using Vercel Cloud, okay? Because this would be easy for me to deploy. Okay. I think it has installed. Now we'll just try to run this command Vercel login. So this is the login URL, and it will automatically launch one website, okay? Authentication website. Now here you have to allow that. Make sure you already logged in with the Vercel, okay? Otherwise it won't be able to select the account. So I already logged in with my Vercel. So that's why, see this account, I will be able to see that, okay? Now I'll just try to give the authorization, allow. Let's wait for the authentication. Okay, authentication is done. Even you will also see the success message here. Hmm. See, it it is getting congratulations, you are signed in. Okay. Now you are also giving the successful message. Now I can close this window. Even I will go get back to my Vercel. Now let me close some of the tab because too many tabs I have created. I'll close this. I'll also close this. I'll also close this. Also close this one. Okay. And this one, I will close this. Okay. Now fine. Now I successfully logged in with my Vercel. Now I have to deploy my application. Okay. Now to deploy your application, you have to run this command. Ah, sorry, not this one. Vercel underscore underscore, sorry, hyphen prod. Now it is asking, do you want to create a new project? I'll tell yes. Use your arrow key. I'll go down. I'll tell yes, create a new project. Now it is telling, please give the name of your project. Let's say I'll give this name. Loop card test sprite. Or let's say loop card project. You can give any name. Now it is telling, do you want to copy all of the source code from your right directory? I'll tell yes. I'll press enter. Now it is telling, do you want to change any setting? I'll tell no. Enter. Now it is connected Git repository. Uh, Connect detected Git repository. I'll tell no. Now it is deploying. Now it's ready. Okay. Now I'll go to the Vercel website. See, my application got registered here. Now I'll click here and there is a live URL I'll get. Okay. Domains. Now I'll open it. Now see, my application is live right now. Okay. See, now even you can also access my application, guys. I'll give the URL. Now tell me, are you able to access my application? No, it only work live application, not local host. Guys, are you able to access my application? Okay. Now let's test. Okay. I'll give save 20. Apply coupon. Now see, this is having the bug. Okay. Now I will run test sprite test cases. Okay. So how to do that? So for this, I have already given all of the command you have to execute. Okay. So first of all, here you have to install the test sprite. Okay. Now we'll try to install the test sprite. So to install the test sprite, what you have to do? Okay. But before that, you have to create one account in the test sprite website. So this is the test sprite website. Just make sure you create a free account. So I already have the account. I'll just try to sign in because you need a API key, okay, from the test sprite. This is the dashboard. And from here, you have to get one API key. Okay, so let's create one API key. So I already created some API key before. I'm going to remove them. I'm going to create a new one. Let's say name it as demo. Create. I'll copy this API key and keep it somewhere safe so that I can use it later on. Let's say I'll keep it here. Okay, just for your reference, I'll keep it here. And right now, what I'm going to do, let's close this as of now. Okay. Now what I have to do, guys, mm, I have to go to the testprite CLI GitHub. Okay. Now here they have already given the installation guideline. So you have to copy these two command. Okay. Now let's copy this command. Open up your terminal, clear, and execute. Paste anyway. So first of all, it will install testprite CLI. Okay. It got installed. Now it will do the setup. Now I'll again execute. Now you have to pass your API key. Okay. Now you have the API key, guys. Copy your API key and paste it here. Okay. Once you have done, you'll see that one folder would be created called Cloud. Okay. See, testprite internally use Cloud. Okay. Internally it use Cloud for the testing operation. Now, see, it got created successfully. Okay. Now inside that testprite onboard, testprite verify. Okay. Whatever utility it needs, it will automatically create for you. Now, the next thing, guys, what I have to do, so we have successfully installed testprite, configured the testprite. We have already set it the API key. Everything is fine. Now, simply we'll try to run the testprite. Now, we'll try to add this project to the testprite server. First of all, for this is the command you have to run. This command, guys. Again, these are the testprite related command. Let me mention test. I'm going to share all of the command, guys. This command will remain same. Don't need to memorize. Testprite related command. Testprite command. Okay. Okay. So first of all, you have to run this command. So this command will register your application in the testprite server, but make sure you have to give your live URL here. So what is my live URL? So this is my app. This is the live URL. Copy that and make sure you are giving the URL here. Once you have given the URL, copy this entire command. Okay. Open up your terminal, clear, and just write execute. Okay. If you do that, it will give you a project ID. Now let's copy this project ID and keep it somewhere safe. Okay. So let's say I'll keep it here. This is my project ID. So don't lose this project ID. Okay. This is required. Now you can go to the testprite website, close it, go to the home. Now see, loopcat project got created. Okay. See, automatically this project got registered in the testprite website. Okay. Now you can see there is nothing right now because we haven't run any kinds of test cases. Okay. So previously I also created some test cases. That's why it's showing. But for you, it would be completely one project. Okay. You can even delete the previous project as well. So now the next thing, guys, I have to execute after registering my application. I have to generate the test plan. Okay. Now to generate the test plan, guys, this is the second command you have to execute. Now you have to copy this ID, the project ID you have copied, and here after project underscore, you have to replace it. Okay. Now copy the entire command, open up your terminal and execute. So it will generate a plan for me. Now you can see it has created a testprite plans folder. I'll open it up. Inside that, one JSON file is created. Now if I open this JSON file, now see, whatever action it should perform, whatever test cases it should perform, it has automatically created by reading my project. Now you can see this is the plan system. Action: open the loopcat homepage and confirm the cart subtotal is $100. Enter save 20 in the coupon code field and click apply coupon. Verify the page confirms the save coupon was applied. Verify the discount is 20. Okay. Verify shipping fee and final cost is $80. Now see, automatically testprite listed down what are the tests it should run in the application. This is the beauty of testprite. Now tell me, if you are a human, for you it would be easy for you to find out these are the step at the very first time of your application. If you are running your own test cases, tell me, guys. No, right? But if you're using testprite, see, easily in just a one command, automatically I got what are test cases I have to run. Even you don't need to run, okay, manually. Test sprite will automatically run. Let me show you. Now what I'll do, guys, here project ID, just try to remove this project underscore ID. This part just try to remove. Okay, this is not required right now. Now save it. Now let's go to the next command. Now after generating plan, you have to run the first test sprite test. Okay, so for this is the command. Now here you have to copy this command. Okay, you have to copy this command. Now this command, what it does, it will open the testSprite.plans folder. It will take the JSON file, as you can see. Save JSON file. Okay, it will take this JSON file, and it will run the test cases over the testSprite server, and it will find out the bugs. Okay, then after that, it will log all of the information in the testSprite server. Yeah, so this is the okay we are using. Now I'll copy this command, open up the terminal, execute. Now see the magic. It will take some time because it will run all of the test cases. Okay, we'll wait. And the beauty is that you can see even the video. Okay, it is automatically going to your website, clicking on that button, giving the coupon code. It will even get that video. Okay, I'll show you. First of all, let's complete that. And definitely you will be getting one failed message. Okay, because your application has a bugs. Okay, it will give you one failed message. I'll show you. Yeah, this is for production only. Okay, this is not a demo purpose. You can use it for the production. People are using that. Everything is happening over your live server. Okay, this is the beauty. This is the application level verifier, and previous example was the code level verifier. Custom verifier we created. Now see, we got the execution result. One thing you have to copy, which is test ID. Okay, just try to copy this test ID and save it here. Okay, this thing I need. This is your test ID. Okay, fine. Now you can see I got a failed message, error message. Now I'll see, okay, what is the error I got? Now I'll go to the test sprite server. Now see, it has run the test, but it got failed. Okay, now I'll see what was the problem. I'll click here. Now it will give me the user interface for you. See, it failed. Save 20 applies. This discount got failed. Okay, I'll open it up. Now see, guys, you can see the preview as well. Now if I play this preview, now see, automatically it saved 20, applied, and it was 89. Okay, that's how, see, it has executed all the step. Whenever it was applied the coupon code, that time my application got failed. Even it has also captured the screen record. How was this process, guys? Tell me. Good. No, I haven't given this recording. It has already recorded this screen. Sir, did you provide whole recording of the webinar to us? It would be available over the krishnaek.in website. Okay. See, that's how, as a developer, now you can understand, okay, I got the mistake here. Now I have to fix it here. You don't even need to fix it. Your AI will fix that. Let me show you. Okay. Now let's say even you can see the code level understanding preview. Okay. But we don't see that. We only see this error. Okay. Now what I will do, I will ask test sprite to download that evidence for me. Let's say whatever error it figured out, right? I have to download that as a evidence. So for this, now what I'm going to do, I'm going to download the evidence. To download the evidence, this is the code, a command you have to run. Here you have to give the test ID. Now I'll copy this test ID. I copy it and paste it here. Okay. But before that, you have to create one folder. The folder name is test sprite failure. So I'll open up my terminal. Clear mkdir. This is the folder you have to create. Okay. Test sprite slash failure. So I already created, I think. Syntax command failed. Okay. I'll only give test sprite. Okay, now it created test sprite folder got created. Okay. Now what I'm going to do, I'm going to copy the entire command and I'm going to download the evidence. See, my evidence got downloaded. Now, if I open the test sprite folder, inside that all of the evidence got saved. Okay. Even that video also. The video you saw right here, this video also got downloaded. This video also got downloaded and whatever error message, okay, whatever cause, fix, everything, it has downloaded here. Just a minute. I opened, closed my, yeah. Just a minute, guys. Let me. Yeah, can you see my screen, guys? Can you see the browser? I think it was closed. Can you see that? Okay. Now see, my evidence got downloaded. Okay, failure, meta, result, all the analysis, all the error, all the bugs it found. Okay, it has given all of this thing as evidence. Okay, now this evidence I'll be using to fix my problem. Okay, now see how what I will do. Simply, I'm going to ask my agent to fix that. Let me show you. Hmm. Okay, now I'll ask my agent to fix that. So I'll give a prompt to my agent right now. Now I'll open my agent. That means your coding agent, whatever coding agent you are using, just try to open. And here give this prompt. Read every file inside test sprite failure folder. Explain why save 20 verification failed. Fix only the root cause. Do not change weaken the test requirement. Save 20 must apply 20% discount and $200 subtotal, resulting $20 discount, $80 should be. After fixing it, show me the exactly what you changed. Okay. Now this is the prompt I have given to my coding agent, and I'm telling just try to refer this evidence as a reference. Why you did the mistake? Why do you have to fix that? Now see if I give this prompt, now my agent will automatically fix it for me. Now I'll allow it. Now you just need to take a cup of coffee and you have to wait. Okay. Now see that. That's how you can solve any kinds of big problem. Okay. See, as of now, I'm showing you a simple project, but in reality, we'll be creating a very complex agent that time or complex project that time it's required. So manual testing that time won't work. Okay. It will take lots of time. That time you can use this test sprite as a verifier. Even though your agent is doing mistake, you can still verify. Hmm. Yes. Now see, it has already fixed inside my pricing.js file. I'll keep that changes. I'll skip it. It's not required. I'll also skip it. Okay. Now you can see previously inside pricing.js, it was 0.02. That means 2%. Okay. So it has changed it to 0.2. That means 20%. So that was the problem in my pricing.js file. Okay. Now it got fixed. Okay. Now we'll redeploy this application. So again, I will redeploy. To redeploy it, you have to run this command npm run build. Okay. You have to build. Then you have to again redeploy. You just need to run Vercel -- prod. Now deployed again, I will go to my live app. Refresh. Now let's test. I'll copy this SAP 20 coupon code. Now apply this coupon code. Now tell me guys, is it correct? Is it correct? Yes or no? Now I'm getting the correct answer. Okay. Now again, I don't trust my application. Again, I don't trust my agent. Okay. Again, I'll try verification. Okay. What I will do, again, I'll open up my terminal. I'll again ask my test sprite to test that everything. Okay. Now to again, what I will do, again, I'll copy my test ID. I'll paste it here. I'll copy this. Okay. And I'll run the test again. Again, you have to wait for some times. Again, it will check everything. Then it will give you the final conclusion. So that's how you have to test your application, guys. Before going for the production, there are lots of test case you have to run. Then you have to uh, let's say confirm your application is completely good. That time you will be productionize your application. This is so important. So if these kinds of case you get in the production, right? So definitely there should be problem. So people will get, let's say you have given 2% discount, your agent is making it as, let's say, 200% discount. That time no price is needed. People will purchase your course freely. It's not good, right? Okay, now see, execution is complete. There is no failed message. Okay, now I'll go to the server again, my test sprite server, go to the home. Now see, the latest test case got passed. Okay, now you can see there is no error. I'll open it up. Even see, this is pass also. I'll open it up. Now even you can see the preview. Now see, I'm getting $80. Okay, now this is completely working fine. There is no error with that. Now I can finalize this application. Okay, now I don't need to run this loop anymore. Today's it's all about harness engineering in agentic AI. And after learning this particular concept, we'll be also implementing a multi-agent system, and we'll try to understand like how this harness engineering works. Okay, each and everything we'll try to see in this session. Perfect. So first of all, guys, what I'm going to do, I'm going to clarify about this harness engineering in detail. I mean, in the theoretical understanding. So after understanding this theoretical concept, we'll try to start with the practical development as well. Okay. So here I'm expecting one thing, one prerequisite should be there for this particular session, which is that you should familiar with AI agents implementation, at least with LangGraph. Yeah, so I'm expecting guys you are familiar with agentic AI at least. Agentic AI means here we create a different AI agents. Okay, and what is AI agents? AI agents is nothing but it's a kinds of applications there we try to automate the workflows. Okay, including some tools. Okay, and some other let's say services like memories, database. Okay, these are the thing we'll try to integrate and we'll try to automate our workflow. Now let's try to understand what is harness engineering then. Okay, so see, harness engineering is nothing but it's a part of the agents. Okay, it's a part of the agents. Why I'm telling it, it's a part of the agents. See, whenever I'm talking about it's parts of the agents, that means harness engineering is nothing but it is your AI agents only. Okay, whatever tools and technology we use for creating these kinds of AI agents, this is called actually harness engineering. Okay, now I think first time this sounds would be a little bit confusing for you, but I'm going to clarify. So as you can see in this high level diagram, we have the LLM, and definitely every agent has the LLM for the reasoning operation for the main brain. Okay, then it has the harness. Harness means it's a controlling system. because agents will have some of the component. Okay, and you know about the component like tools, memory, database, right? With the help of that, it controls something. So let's say whenever you are assigning any kinds of task to the agents, so this particular task it will take as a goal, and it will divide that goal as a multiple task, and this task would be done by these kinds of controlling component. Okay, let's say you are telling your agents to generate an email and send it to the customer. So what it will do, it will first of all generate the email. It will verify whether this email is fine or not based on the user topic. Then it will automatically use your email tool and send the email over the customer. So each and everything is being automated here. Okay, we are creating the automated pipeline, and the entire system we call it as a production app. Okay, entire system we call it as a production app. Now see guys, here what are the things we're going to learn in this particular session. First of all, we'll see what is harness engineering means, AI, agentic AI. Why a good prompt is not enough for production. Okay, how routing, state, guardrails, and validation works. How a harness controls multiple specialized agents. How Langra fits into the harness, and how to think about production reliability. Okay, so see guys, first of all, let's try to understand the problem. An LLM call is not a production system. Okay, I think those who have already studied about generative AI, I think you know that. Previously, the application we used to create, we call it as a prompting based application. There we had a single large language model, and user will send some kinds of prompt, and he will be getting some kinds of direct response. Okay, but what was the missing in this particular area? That means the first missing component was the safety, then routing, validation, then permission and observability. Okay, production system needs software around the model to decide what's happening before, during, and after the agents run. Okay, now we can see what is harness engineering. Then harness engineering is the design of the control layer around AI agents. Okay, that means whenever we are developing an AI agents, that AI agents need some of the component. First of all, routing is required. Routing means who should do what kinds of work. Let's say we are creating a multi-agent system. Okay, and multi-agent system means there would be multiple agents. Now whenever I'm getting a task from the user, we have to decide which task should be performed by which particular agents. So this is called routing. So agents will have this routing features, so that agent can automatically route the task. Let's say you are creating a customer support agents that can solve technical query, general query, as well as the, let's say, any kinds of let's say financial query. Now whenever a user is giving a prompt, let's say user is giving, I'm having some problem with my software X. Now can you tell me what kinds of question it is, whether it is technical, financial, or general? Tell me guys. Let's say user is having a problem, I'm having a problem with my software X. Now this is related for what? Definitely technical. Okay, now if I'm sending this request to my financial agents, so will it be able to generate the response in a correct manner? No, definitely, right? So that's why we have to use the routing means it will automatically decide the questions we are getting, the task we are getting from the user, which agent should I route it, right? So this is called routing, and this component should be available in every AI agents. If you, especially whenever you're creating the multi-agent system, guys. Okay. Then the second thing is the state. Okay. State means what do we know? That means whenever we are having the multiple agents, let's say agents A, agents B, agent C, agent D. So let's say the first agent is working, and it will have some kinds of input, and it will also give some kinds of output. So this is called actually state data, and this state data we have to save somewhere. For this we use some kinds of state memory. Okay, this is another component of an AI agents. Then you have the guardrails. Okay, guardrails means this is the safety features. That means what kinds of input you should allow, kinds of input you should not allow, what kinds of output you should allow, what kinds of output you should not allow from your AI agents. Okay, that means if anyone is asking any kinds of violation related prompt, if anyone is asking any kinds of, let's say, harmful or sexual content, definitely you have to block that particular request. And how you will be doing that? With the help of guardrails you can do that. Okay, so guardrails is also part of an AI agents. Okay, then you have the validation is also part of a guardrails, but here we just try to validate the output. Okay, output means, let's say we are generating a content from the agents. Let's say we are generating a technical blog. Before publishing this blog, first of all I want to validate that whether this particular blog is correct or not, whether the code I'm having it is correct or not. Okay, we perform this validation. Now most of the people here, they can recall the concept we have learned in our previous webinar, guys. Can you tell me what we do inside this validation? Can anybody tell me here? If you have joined my previous webinar, guys, what we perform inside validation? Do you remember the loop engineering concept, guys? What is loop engineering does? Loop engineering means no. Loop engineering means it will take the output, then it will verify. It will verify that. Okay, it will verify and give the feedback whether this particular output is good or not. If not output, if it is not good, then it will send the feedback to the agents. Agents will again generate something. Again, it will do the validation. That's how this loop will be running. Okay, and there would be some termination condition unless and until this particular output is not good or it is matching with our maximum threshold, this loop will continuously run. Okay, this is called loop engineering. We have already studied in our previous webinar, guys. Get it? Then the tracing. Okay, tracing is also important. You have to also trace each and every execution. Either you can use any kinds of tracing platform like Langsmith, okay, or Langfuse, or you can also use any kinds of memory for that. Okay, but you have to trace you what is happening inside every nodes. Okay, this is what your I mean, all of the components whenever we are developing any kinds of agentic AI applications. Okay. Now, if you combine all of them and if you create one applications, we call it as a harness engineering. That means, see, to implement the agents, okay, we only don't need the large language model. Apart from large language model, we need some additional component. We need some additional controlling component, like tools can be there, routing can be there, state can be there, guardrails can be there, validator can be there, tracing can be there. If we combine all of them together, this is called harness engineering. Okay, that means harness engineering is nothing but the controlling workflow. Okay, to operate an agents, what are the controlling tools are required? We call it as a harness engineering, guys. Is it clear, all of you? Let me know. Is it clear, guys? To implement an AI agents, whatever controlling component we need, this is called harness engineering. That means harness engineering is a part of your AI agents. This is not a separate field, guys. That means whatever agents we create so far. Okay, we used to know that about harness engineering. We are not sure about this is called harness engineering. Now we are pretty much clear about that. So the model decides intelligently and harness decide operationally. Okay, that means I told you an AI agents will have two components. One is the large language model and another would be the controlling layer. So model decides the intelligence, okay, about the work, but harness decides the operational. That means to perform the kinds this complete automation, it needs to perform some operations. Okay, this is how your harness engineering helps us. It will use tools, routing, state, guardrails, validator, tracing, each and everything here. So harness is not a making it powerful around the agents, make the most of LLM. Yeah, harness actually making your agents powerful at the end, right? Because without routing, state, guardrails, validation tools, how your agents should be powerful? Okay, how it should be automated? Okay, Krishna, I think you are getting my point. Okay, with a simple large language model, also you can create the agents. But this should not be a perfect agent. To create the perfect agents, we need all of this component, and this is the part of harness engineering is. Okay, now let's try to understand from a real world analogy. Okay, so the analogy is engine and car. Okay, so let's say you are driving a car and you know inside a car there should be some kinds of engine, right? Whether you are driving Toyota, Nissan, or any other like brand, each of the car will have an engine. So just try to consider engine is nothing but the LLM. And what is harness? Harness is nothing but the car controlling system. Let's take an example. Let's say steering. Steering means, let's say this is called routing. That means with the help of steering, you can change the route. Then brakes. This is called guardrails, like where you want to brake the car. Okay. You have the entire, let's say, blocking sector here. Okay. In the brakes. Then dashboard. Dashboard is nothing but your observability. Transmission. This is your workflow. Seat belt. This is your permission. Okay. So that's how you can compare your harness with the real world analogy. Now I think you are pretty much clear, guys. What is harness? That means LM is the engine and harness is the component of a car. Get it? It will be available over the website itself. Okay. Deep. Okay. So this is the simplest explanation I can give you about this harness engineering. This is nothing. This is the part of AI agents only. Okay. But harness means we are adding some other controlling layer to the agents, okay, so that our agents can be more powerful, because the single LLM based agents can't automate the process. For this, it needs some controlling tools. Okay. And these controlling tools, we call it as a harness engineering. This is called harness, adding harness to the agents. That's it. Yeah. Now let's try to understand some application concept like prompt based application, context based application agents versus harness. Now, see, in prompt based engineering or application development, we used to use a prompt. Let's say we are having a single large language model, and here we are sending a prompt. What should I tell the model? Okay, so this is our goal. Then we had something called context engineering. This is also called RAG, retrieval augmented generation. There, the main goal is that what information should it see? That means the large language model we are using, we also provide some additional context from the knowledge base. This is called context engineering or based solutions. Okay. Then we had something called agent engineering. Okay. So basically here we just try to assign the role tools should it have, right? And to make it completely automated, okay, working controlling agents, we add the harness engineering. That means how should whole system operates, okay, to perform a task, how it should operate all of the component. This is called harness engineering. So this is the difference between your prompt engineering, context engineering, agent engineering, and harness engineering. I hope you get it. And loop engineering is the part of harness engineering. Okay. Because inside harness engineering only you are having that validator section, and inside validate you perform the loop engineering. Get it? Hmm. Now let's try to understand why we use multiple agents. Okay, why not single agents? Especially nowadays, if you are developing any kinds of agentic AI application, or if you are seeing any kinds of agentic AI applications, you will see that people are creating multi agents, okay, instead of single agents, because one giant agent cannot handle all of these. I mean, let's say billing, tech, sales, refund, everything. This would be a little bit difficult for one agents. Okay, so harder to control, test, debug, secure, and improve independently. Okay, but if you're creating specialized agents, that means multi agents, you can divide the task. Let's say for technical query, you can create a technical agents. For billing related query, you can create a billing agents. Okay, for general question and answer, you create a general question answer agent. So whenever you are getting some kinds of output from the users, you can divide the task. So for technical query, you can pass this task to the technical agents. For billing related query, you can pass it to the billing agents. Okay. For general question answer, you can pass this task to the general question answer agents. That's how you can create a specialized agents. So in our real life also, people are not actually perfect with all of the work we're having in this world, right? So every human being is having some kinds of specialized. Let's say someone is very good at computer vision, someone is very good at, let's say, machine learning, someone is like very good at AI agents development. They're specialized things, right? And every company is having this kinds of specialized engineer. So they're not going to hire someone who knows everything. Okay, because in a company you will see that that would be a separate HR, there would be separate CEO, there would be separate, let's say, manager, there would be separate engineer. Okay, each and everyone is a specialized agents there. They're working together. They're working. As a team, okay, and they're solving a very complex problem, and they're growing the company. So things are same here. We are creating a specialized agents, okay, multiple agents, and we are giving some special task to them. And whenever we're getting these kinds of tasks, we're dividing the task between them, and they're working together and they're solving a big problem here. This is what our multiple agents does, right? But expensive utilizing multi-agents. Yeah, definitely, to create a multi-agents, it should be a little bit expensive, but at the end, the agency will be developing. This should be more robust. Okay. Right now in industry, people are more worrying about the robustness, okay, instead of the cost. Because if you're not creating a robust agents, so what is the mean of that particular application if it is not solving the real world use case? I hope you get it. No, no, no. It will not forget because it will have a state memory. Okay. Yeah, this thing we have to learn inside AI agents development, guys. That's why I told you AI agents knowledge are required. Okay, and there will be learning something called lang graph and state memory. Okay, we create a permanent memory for each and every agents. There is a concept called subgraph. Okay, So with the help of subgraph, you can create this multi-agent concept inside LangGraph. Have you studied subgraph before, anyone? Subgraph, subgraph in LangGraph. Okay, this is the best way to create the multi-agent system. Yeah. No, state graph is a different thing. Subgraph is a different thing. Okay. If you don't know, you can check my YouTube channel, TS with Bappi. There I already have the tutorials. You can understand about the subgraph. Yep. Okay. That's why LangGraph is like very full and most demanding framework nowadays, especially in industry for the agents development instead of any other framework like Crew AI, AutoGen, N8N. Okay. People are more focusing on the LangGraph development, especially whenever you're getting your custom agents. Okay. So try to master LangGraph. That would be pretty much beneficial for you. Hmm. No, this is just a simple, React agent. Okay, Gaurav. Create underscore agent. This is a simple React agent inside LangChain so that at least whenever you are learning something, you can use that and create a simple basic agentic application. Okay, we don't use this create agent in real world. Your YouTube channel name and LinkedIn profile. DS with Bappi. Okay, DS with Bappi, my YouTube channel, and Boktiar Ahmed Bappi is my LinkedIn profile. Yeah, let me show you. So this is my LinkedIn profile. Okay, and this is my channel. This is my channel. Hmm. Okay, now let's try to see an example of this harness engineering. That means the harness agent. We'll also create this thing in a practical. Okay, first of all, let me show you the high level diagram. So here we are going to create a multi-agent system, guys, and this is going to be a AI customer support agents. So user will give some questions, okay, or let's say any kinds of customer related query. First of all, we'll try to pass through the guardrails layer. Okay, so definitely guardrails should be the component of the AI agents. First of all, we'll try to check whether the questions we are getting it is having any kinds of violation, it is having any kinds of, let's say, harmful content or not. If it is having, we'll try to block the request. Okay, otherwise we'll try to send it over the router. Okay, what router will decide the questions we are getting. Let's say if people are asking about, let's say I'm having a error inside my Python program. Now, can you tell me what kinds of question it is? It's a technical, billing, or general? Tell me. I'm having a problem with my Python file. Let's say this is the question. Technical. So what router will do, it will automatically understand the user question, okay? And based on that, it will route that particular questions to the specialized agent. So here specialized agent should be my technical agents. And technical agents will try to generate something, okay, based on the user query, and it will pass to the reviewer. See, before passing to the user, we will do the review operation. Okay, we'll try to see whether this, I mean, answer it has generated. This is perfect for this query or not. If it is perfect, then we'll try to show. Otherwise, will not show. Okay, so that's how. If user is passing any kinds of billing related questions, we'll try to send it over the billing agents, and billing agents will give it to the reviewer agents. Reviewer agents will try to review, then we'll try to show. Similar goes to general question and answer. Okay, so here we'll try to create a 3 agents, and each of the agents will have different responsibilities. Okay, that's how we will create a multi-agent system. And to create this multi-agent system, guys, you can see I'm using all of this harness concept. Okay, harness component, and this is what your harness engineering is. That means the simple AI agents implementation only, but we are using all of the component. Apart from that, there are some other components are also available, like memory, then you have database. Okay, but in this particular demo, I'm not going to use all of them, because if I'm using that, it would be very long session. That time it would be very big project. Maybe in future we'll try to see the complete end-to-end implementation, but at least just to show you the demo purpose, I'm going to create this particular agents. Okay, with these are the component. I hope this part is clear to all of you. What exactly the control is happening? So here is the control happening, right? So whenever user is passing something, right? Let's say user is passing a questions about technical, so this routing is automatically decide it will hit the technical agents and it will send it to the reviewer. So here this controlling is happening. Here we are not controlling, right? Here our agent is deciding where it should go. Okay. In real world also, let's say if you're creating a automated agents, that time let's say you are handling the email. Let's say regular basis, whatever email you are getting from your customer, first of all you are checking to the guardrails, then you are giving to the router. Then router is deciding what kinds of email it is. Based on that, it will trigger that particular agents. Then it will generate the response. It will pass to the reviewer, and reviewer after reviewing, you will send this particular let's say message to the sender. Okay, sender agent, and sender agent will try to again resend that particular email to that customer. Okay, that's how you can automate the process. But right now we are not adding too much layer in this particular development. Get it? If I remove the guardrails, then it will be multi-agents, like it will be similar to multi-agents. See, if you also remove the guardrails, yeah, this would be multi-agent definitely, but this will not have the harness concept that time, because you are losing one part of harness, which is guardrails, and guardrails is super important right now inside the agents. Okay. Otherwise, people can ask, I want to hack your platform. Okay, give me the let's say weakest point of your platform. Okay, that time there is a possibility your agent may give that particular weakest point, and people will hack your system, right? So that's why guardrails is important. If you open ChatGPT and if you ask how to make bomb or how to hack, let's say Google server, just see whether ChatGPT gives the answer or not. Try just anyone try from here. Let me know. Notes the entire guardrails is equal to harness. Harness means the entire component. Okay, entire component. Guardrails, router. Okay, memory, tools, everything. If you include everything, then it will become a harness. Nazar. Okay. So have you tried guys with ChatGPT how to make a how to hack Google server? You will see that it will not give you the answer. Why? Because it has the guardrails layer. So every input you are giving to ChatGPT, right? Let me show you. So if I open up my ChatGPT and if I'm asking, let's say, how to hack Google server. See, I can't provide the instruction for hacking the Google server. This contrast cannot be shown, okay? Because this is not matching with their okay policy. This is a violation, okay? That's why it is blocking your request. Get it? So that's why every real world application is having this guardrails concept. Okay, without guardrails, definitely you don't need to create any kinds of application. Otherwise, there is a possibility your application can be used in a okay different manner. Hmm. So here, this is the flow, guys. The entire system flow. First of all, user will give the questions. I have an API login added. It will go to the guardrails, and guardrails will either decide whether it has to block or not. Then it will go to the router nodes. It automatically detects like it is a technical query. Then it will prepare something draft. Okay. Then this draft would be shown to the reviewer. Reviewer will generate the final answer. Then it will trace and it will show the user. Okay. So here one thing you have to important, which is that don't use an LLM for every decisions. Okay. Sometimes for some example, you can use deterministic code. For some kinds of decision, you can use LLM decisions. Let's say for any kinds of low level task, let's say you want to see whether any refundable message you are getting from the user or not. Let's say if user is asking for the refund. Okay. So that time you can simply write the deterministic code, like you can simply use the if else condition to handle this kinds of scenario. If refund it is available in the questions, then try to uh, route should be the billing. Okay, they're asking for the refund of the billing. Okay, but if their question is having some complexity, let's say classify this request into technical, billing, or general, that time actually you can't use this deterministic code. That time definitely you have to use the LLM decisions. Okay, so it's your design pattern always. You don't need to use large language model every sort of task, sometimes deterministic code will work. So if you're adding the deterministic code, you can reduce the cost of your agents. Okay. That's how you have to think about. If you are having a low level task, low level, let's say conditions, that time use the deterministic code. And if you are having a high level task and needs some more reasoning to understand this particular content, that time use LLM decisions making. Okay. I hope you get it, guys. That's how you can reduce the cost of your multi-agent system. Hmm. So guardrails is the entirely no, guardrail is not managed by the provider. Okay, LLM provider. It would be managed by you, especially inside your applications. Okay. Yeah, but right now, whatever LLM provider we use, okay, they also have some kinds of guardrails integration in the model when they train the model, right? But again, whenever we are creating our custom application, that time we have to use our own guardrails logic there, Nathan. Hmm. Now, this is the guardrails control workflow. So incoming request, first of all, we'll apply the guardrails. If this is matching with our requirement, we'll try to allow it. Otherwise, we'll try to block it. Okay. Then specialized agents. So it will basically draft an answer. Then we'll pass to the reviewer. Reviewer will generate the final answer for that. Okay. So yes, this is how actually we'll try to create the entire system, guys. And this is the high level architecture I created for you. There are some live demo, like I will ask some of the questions, and based on the questions, it will automatically route the questions to different specialized agents. Okay. So yes, now let's try to see the practical demo, guys. Okay. Okay. Now, guys, we'll try to start with the practical. So let's do one thing. I'll open up my local folder, and here let's open up our VS Code. So I think everyone is having VS Code in their system. Yes or no? VS Code, Anaconda. This is installed, right? Yeah, great. So let's open up our VS Code. Mhm. Okay. Okay. The first thing, guys, you have to set up the environment, and you know how to create the Conda environment and all. But again, I'm giving you all of the command. So to create the environment, you have to execute this command conda create. You can also use UV package manager. This is also fine. Okay. But I'm going to use conda create -n. You can give the name of the environment. Let's say I'll give demo, and then Python version. So let's say Python is equal to 3.11. Okay. -y. That means I'm giving the yes permission. Then you have to activate the environment. So to activate, you just need to write conda activate. Okay. Activate demo. Then after that, you have to install the requirement. So pip install -r requirement dot requirement.txt. Okay. So you can copy all of this command one by one and execute in your terminal. So for me, I already have the environment. I'm going to directly activate that. See, you can also use VS Code terminal. At the end, both are same. So I'm using separate terminal because I like to use that. If you open the VS Code terminal, see what will happen. Let's say if I open the terminal, so it will occupy extra space here. Okay. So this code readability is not good here. So that's why what I do, I use this separate terminal section. So I can anytime minimize it. I can anytime launch it. Okay. That's why you can use anything. Okay. No need to worry. Yeah. So now let's create a GitHub repo. I think there I'm going to commit all of the code. I think that would be amazing. So I'm going to create a GitHub repo. So what I can do, I can, let's say, mm, I can create a new repo. Hmm. So here I can name it as harness engineering. And let's copy from here. I'll copy this name. Yeah. Harness engineering in Agentic AI, multi-agent demo. Harness engineering, multi-agent demo. Multi-agent demo. Hmm. Now let's keep it as a public visibility, and I'll take the README file. README I am already having. Let's take the git ignore. I'm using Python programming, so let's select the Python. Python. Okay, why Python is not coming? Now it's coming. Now give the name. License, you can take any license. Let's say I'll take Apache license and create the repo. After that, I will clone this repository, guys. Click on code, copy this link address, open up your folder, and in the terminal, just write git clone, paste this URL. Okay. Now let's clear. And what I'm going to do, I'm going to copy all of this file and paste it here. And I'm going to remove it. Now let's open up my VS Code again. Yeah, so now my repository is available. Okay, now I can commit the changes anytime. Okay, but before that, let me just activate my environment. I already activated. Now let's install the requirements. Okay, so let me mention all of the requirements you need here. So first let me create a file. I'm going to name it as requirements.txt. And here I need fast API. Okay, why am I? I'll be using fast API because I also want to create a backend API and with a user interface. User interface that's to run the fast API server. You need UVCon. Okay, let it start it. Okay, yeah. So yeah, these are the package, guys. We'll be installing. Let's install. So I'll open up my terminal and execute this command. Okay. For me, it is telling requirement is already satisfied because I already installed previously. Okay, but for you, it may take some time. And it's a good practice. Whatever package you are installing, right? Just try to get the version and mention it here. Why this is required? Because if you are running this project after 1 or 2 months, if there is any package update, you won't be having any kinds of problem. Okay. So let's first of all mention the fast API version. Yeah, this is the requirement. Okay. Don't worry, I'm going to commit the changes. Okay. So this is my GitHub. Here I'm going to commit. Let me show you the GitHub link. So this is my GitHub link, guys. Here I'm going to commit my changes. First of all, let me complete. Okay. Jinja basically helps to load the HTML CSS page code. Okay. Krishna in fast API. So fast API, what is the package version of fast API? It's 0.141.1. Okay, let's copy that and mention it here. Then UVCon. So what is the UVCon version? UVCon, UVCon, this one. Copy that and mention it here. Then Jinja 2. This is the version. mention it here. Then python.env. Then langgraph. Langgraph, this one. And langchain grok. Because we'll be using grok provider to access the grok LLM. Langchain grok, this one. Yeah, I can do you with the help of pip phrase, but if you do pip phrase, right, it will save all of the dependency package. Let me show you. See, all of the package. Okay, all of the package. So I feel like, okay, this is like more confusing because at the end, these are the packages are required, but these are the also dependency package. Okay, that's why I don't need to install it again. So if you mention that, it will automatically install its dependency package. It's like more clean way to understand. Okay. Yeah, otherwise people will ask, sir, what is this markup safe? What is light LLM? Okay, these are the thing people may ask you. But again, these are the package installed from this package only. Get it? That's why. This is more clean way to understand. Okay, now requirements is already added. We created the environment. Everything is ready. Now, first of all, here we'll be collecting the API key. So let's create a file. I'm going to name it as .env. And inside that, I'm going to collect my grok API key. Okay. Grok API key, because I told you we'll be using grok large language model. Sorry, it should be equal sign. Okay. Now, how to get the grok API key, guys? Simply, you just need to visit grok playground. Okay. Grok playground. Make sure you are creating one account. If you don't have the account, I already have the account, guys. I'll just try to log in with my account. Okay, after login, there you have the API key section, but here you can see there are different models you can access. Okay, I'll go to the API key section, and here you can create a new API key. For me, I already created an API key called demo, and this API key I'm going to save it inside my .env file. And don't use my API key, guys. Okay, otherwise let me create a new one so that I can remove it after this session. Okay, so I'm going to name it as harness demo. Make sure you are selecting no expiration and verify and submit. What model are free in Grok? I'll tell you. Copy that and mention it here. Okay. Yeah. See, you can access almost all the model. Okay. As free, but there are some uh, limit you will get. Okay. That means the request limit. That means in a single day, let's say that much token input and output you can spend. Okay. Once it is done, you are not eligible for the free tier. Again, you have to try next day. Okay. But if you want to hit unlimited request, that time you have to take their premium subscription. Get it, Krishna? So almost all the model you can access from here. So Grok API key we have collected. Now let's create a file called agent.py. Okay, then I'm also going to create app.py. I'm also going to create graph.py. Okay, and again, I'm not going to explain, guys, about the langgraph. What are the things where available inside langgraph? I'm expecting you are already familiar with langgraph. If you don't know, please try to complete the langgraph first of all. Okay, but here I'm expecting you are familiar with the this langgraph concept. Okay, so here I'm not going to write the code from scratch. Okay, because at the end, if you understand the langgraph component, you can easily write the code. Okay, most of the code, ready to use code, you can use it as it is. Okay, now the first thing, guys, will be developing the agent, because if I show you my architecture, so this is the architecture. Yeah, here is the architecture, guys. First of all, here we'll try to create all of the agent. That means our technical agent, billing agent, general agent. Okay, let's create that. Then we'll try to combine them all together. We'll add the guardrails, router, reviewer, each and everything we'll try to create. So let's create the agent now. So to create the agent, first of all, you have to import some necessary library. Like I need operating system. You also need to import grok. So from langchain grok import chat grok. And we'll be using one model. The model name is 3.17 llama 3.1 llama 3.18b llama there. I think llama is there, right? This llama prompt guard, this model available. Okay, no need to worry. Maybe I can use this model. This model I can use. OpenAI GPT OSS 20p. Okay, this model I can use. And if you want to use this model, this is the model ID. You can copy and you can mention it here. Okay, this is the model. Then after that, you have to, one thing I want to verify. This is fine. Now, what I will do, guys, I'll load this model. Okay, for this, let's create a function def get LLM. Older llama model, maybe they have removed. Okay, yeah. Get LLM, and we'll just try to return chat grok object. That means our model object. Okay, model endpoint. So model is equal to model name. Okay, then you have to mention the temperature if you want. Now, can anybody tell me what is temperature? You know about temperature in LLM, right? That means this is the creativity parameter. Okay, API key is equal to os dot get env, and I'm going to load the grok API key. So this is the API key. Okay, then after that, let's test this model. Okay, whether it works or not. So simply I'm going to call this function LLM is equal to get LLM, and we'll do the invoke operation LLM dot invoke. I'll give hello. Let's see whether it works or not. And the response I'm going to get, I'm going to print it here. So I'll open up my terminal. Clear. Python agent.py. Okay, one error I'm getting, which is that grok API key to the client was grok API key in environment variable. Oh, okay. Can anybody tell me the problem? Problem is that here I haven't loaded the .env, right? From .env input load env. Okay, now you have to load the environment variable. Now it should work. Let's see. So you can see, hello, how I can assist you today. If you want to only get the content, simply you can write r.content. Okay. So it's working fine. Okay. So simply we are able to make the connection with our growth provider. Okay, and we're able to access the large language model completely free. Okay, free of cost. Okay, now let's try to create our agent. So the first agent, guys, I'm going to create called technical agent. Okay, that means this agent, technical agent. And what technical agent will do, it will handle the technical related query. Okay, so I already created one technical agent function. Let me show you. Very simple. So this is the technical agent function, guys. Just try to see. Okay, what I have done. I created a function called technical agent. This takes the user question. Okay, and it calls the LLM. Okay, it calls the LLM, and this is the LLM object. And here we are preparing the prompt, entire prompt for the technical question handling. So we are telling you are a technical support agent. Your job is to help with a login problem, API error, installation problem, bugs, technical setup. Explain the solution in very simple step. Never invent account and specific information. If important information is missing, carefully say what the user should check. Okay. And customer question, this is the question, and return only the helpful answer. Then we are invoking the LLM with the prompt and taking the content and returning it. So guys, are you clear till here? Yes or no? Yes or no? Clear, guys? Great. Now let me define the next agent, which is billing agent. Okay. Billing, then general, then also reviewer. Okay. These are the agent. We'll try to create one by one. Now again, I prepared another agent called billing agent. This is what your billing agent. Okay. So again, you can see the name of the function is billing agent, takes the question, calling the LLM, and this is the entire prompt. You are a billing support agent, demo company policy, starter plan $10 per month, pro plan $25 per month. Refund request must be reviewed by the billing team. Never claim that the refund has already been approved. Never asked for full card numbers or passwords. Customer questions always clear and safely using only the policy above. Okay, then we're invoking the LLM, returning the content. So in the prompt, there is a constraint and one shot example. Yeah, you can add the one shot example. There is a constraint. You can also add the example. Okay, this is completely your designing. Okay, if you want to add this kinds of prompt, you can do that. The way I'm writing, it's not necessary to write. I mean, you can also write the same thing. You can change it. Now, Bling agent is also ready. Now I'll try to prepare the general agent. Okay, let's open the code again. And this is the general agent. So basically, this will handle the general question and answer. So this is the general question and answer. Again, we are writing a detailed prompt about the general question and answer. We are returning the output. Okay. Then once we have created all three agents, okay, then we'll also create the reviewer agent. And what reviewer agent will do? It will review the output given from each and every agent. Okay. So again, here I'll try to create a separate agent for that. For reviewer agent, it will take the questions as well as the draft. Okay. What draft? Each and agent, every agent, whatever draft it will return. Okay. It will take that draft and it will verify whether this question and this draft is looks good or not. So for this, it will call the LLM, and this is the entire prompt. You are the quality review agent in a production customer support system. Check the draft for draft answer for clarity, relevance, unsafe request or password card number, unsupported guarantees, unnecessary complexity. Rewrite the answer if needed. Okay, keep the final answer concise and beginner friendly. Original customer question, and this is the draft answer we got from the agents, and return only improved final answer. Okay, and we are invoking the LLM again. Okay, so this is our reviewer agent is. That means all of the agents we have created successfully. Now we'll try to create the graph. Okay, because in line graph, the graph object is the main object we create. Now I'll try to define the graph here. Yeah, let's commit the code guys still here. So what I'm going to do, I'm going to commit the code. So git add space dot git commit hyphen n hyphen m agents added, then git push origin math. So code is pushed. Now if I show you my GitHub, so code is available now. Okay, you can test. You can check my GitHub, guys. Okay, now we'll try to create the graph, guys. Okay, so this graph is everything inside LangGraph. So let's try to import some necessary library. I need this type dict and literal from typing. Then from LangGraph, I need state graph start and end. Again, don't ask me where we are importing that, because again, I told you this is the concept of LangGraph. And to create a graph, guys, I need these are the libraries. Okay. For this, you have to please study about LangGraph. Okay. This is the requirement. Now, whatever agents we have created, guys, inside our agents file, we'll also import that one by one. So import, first of all, we'll import the technical agents, then billing agent, then we have general agent, then we have reviewer agent. Okay, we'll import all of the agents. After that, we'll try to create the state memory. Okay, I told you state memory is also part of a harness, right? So in LangGraph, we create a state memory like that. We just write a custom class for that. Let's say the class name is support state, and this is inherited with the type dict. Okay, because type dict is a type. This will store your data as a dictionary. And you can also store this dictionary in a permanent database. If you want, you can also integrate a database. We call it as a state memory database. Again, this is a concept of LangGraph. You have to study about. Okay, you can either use PostgreSQL, either you can use SQLite, any kinds of database you can integrate here. Okay, but as of now, I'll try to save everything in the memory. That is my our RAM. So here I have taken some variable in this memory, guys. The first variable is the questions. That means whatever question user will ask, it will save inside the question variable. Then route. Okay, route means, let's say here. So let's say the question user is asking and router is deciding what kinds of agent should be running. Let's say for technical question, technical agent should be calling from the router. So this information will save inside the router variable, guys. Okay, route. Then draft. Draft means each and every agents will generate some draft. This draft result will try to save inside this variable. Okay, and final answer. Final answer means your reviewer agent, if it generates any kinds of final answer after reviewing it, will try to save it here inside the final answer. Then block. Block means if your guardrails blocked some kinds of request, okay, or if accepts, will try to save inside this particular variable. And trace. Trace means all of the execution will be doing, right? Whatever things are happening in between each and every node, we'll try to save that information in the trace, and this is going to be a list type data. Okay, that means inside the list, we'll try to continuously add on the execution trace. Okay, this is how our state look like. Okay, can you use Neo4j as a memory? Neo4j is not recommended in LangGraph, but you can use Postgres. This is the most used one. Nazar, because here graph database is not required. Okay, because this is state-wise data. I mean memory we need. Okay, now successfully we have created the state. Now we have to create the guardrails, guys, because guardrails is also a harness inside a agent. Now let's create this harness function. I'll write a custom function for this harness. Sorry, this one, guardrails. So this is the custom function I have created, guys. Guardrails node. So this takes the state memory, and what it does, this is a simple deterministic safety layers. It in real system, this can be included moderation, PIL detection, okay, permission and policy checks. Again, I told you guardrail itself is a big topic. You have to understand it separately. For this, I already have a tutorial. You can check it out. So first of all, we are checking the questions, user questions, and this is the deterministic one. And what does deterministic means? Deterministic means that means it is a conditional based guardrails. Okay, if you want, you can also use LLM based guardrails, but for LLM, you have to take one LLM here and you have to give a prompt whether the user question having any kinds of let's say harmful, violation, sexual content or not. Okay, if it is having, just try to block, otherwise don't block. And here we are using the this one, actually deterministic one. That's why we are taking a list. Inside list, we have taken some sentence like give me your password, steal password, full credit card number. If these are the information is available, just try to block it. Okay, and save the trace in my trace state. Okay, So you can see if block just return this particular output to the customer or user. I can't help you with this request involving the password, stolen credential, or full payment informations. Otherwise, just try to make this block as false. Okay. That means if my content is having any kinds of sexual harassment violation content, it will block. That means block parameter would be true. If it is true, that means we'll just stop the execution of the workflow and we'll show the user we can't help you with that. If it doesn't have the violation, that time we'll just try to make it as true. Okay, then we'll just try to execute the remaining workflow. That means we'll try to execute our router, our technical agent, billing agent, okay, reviewer agents, everything we'll try to execute. So this is what your guardrails function is, guys. Okay, and this is a custom function you can use either as it is. Guardrails is a part of governance. Yeah, you can consider it's a part of also governance. Okay, now this is another function I have written after guardrails. What will happen? That means if my state is blocked, that means directly my node will go to the end node. That means my execution will end. Otherwise it will go to the router node. That means router node will decide, see what is happening. If your guardrail checks any kinds of input which is having violation, it will go to the directly end nodes. That means execution is over, no more execution. But if it doesn't have the violation, that time it will return this user input to the router. So this is the function it will do. So till here, guys, everything is clear, all of you. And again, I'm telling you, if you know about line graph, this would be easy for you to understand. But if you don't know, it would be a little bit harder for you. Get it? Yeah. Now we'll try to create this router node, guys. Okay. Now router will decide based on the user question where it should send the request, whether it should send the request to technical agent, billing agent, or general agent. Okay. So let's try to define that particular function. So here, what I'm going to do, guys, I'm going to just create a function. This is the function, guys. Actually, two functions I have created. Now here we have created this router nodes, guys. So what router node does based on the user question, first of all, it will check the technical words. Okay. Now see, again, I'm using the deterministic approach just to show you the demo, but in real world, you have to use some kinds of large language model to understand the user intent or user questions, whether this is technical, whether this is billing, or whether this is any kinds of general question answer. So here I created a list for the technical question answer. If this question is having any kinds of error, bug, logging, API installation related word, I'll consider this is a technical word, technical questions. If it is having this kinds of word like price, pricing, payment, refund, bill, I'll consider as a billing word. Okay. And if it is having none of them, that means I can consider this is a general one. Okay. So this is what we're writing this condition here, and we're returning the router. Now here I have created another function called choose agent. So what this choose agent will do, let's say if our router, okay, if our router is equal to technical, it will call technical agent. If our router is equal to billing, okay, that means if it is returns like billing, that means we'll call the billing agents. Otherwise, we call it as a general agents. Okay. Now we have already created all of the agents, technical agents, okay, then billing agents and our general agents. We'll call these are the agents one by one. And this function will redirect here. That means this condition we are writing right now. I hope this part is clear, guys. Okay. Now let me write the next code, which is nothing but our my nodes. Okay, now I'll try to define all of the nodes. Let me define the nodes, because in LangGraph nodes is important. You have to create the nodes separately. So this is the nodes. Okay, the first nodes I have created for the technical nodes. Basically, this hits the technical agents. Okay, if you are having a technical related question, it will hit the technical agents and it will return you the answer. Okay, and every execution are tracing this information in the state memory. Then billing nodes, it will hit the billing agent. Okay, then general node, it will hit the general agent. Then reviewer node, it will hit the review agent. Okay, that means all of the agent we have imported, we are executing one by one. Get it? So once we have defined all of the nodes, now we'll try to create the graph. Okay, now how to create the graph? Again, this is super simple. Let me show you. This is the graph, guys. If you understand graph in LangGraph, it would be easy for you. So first of all, we are adding all of the nodes one by one. First of all, we're adding the guardrails node, router nodes, technical agents, billing agent, then just a minute. Okay. Then general agent, reviewer agent, then we are adding the edges. That means the connection between the agents. That means here this router agent would be connected to the technical, billing, then general. Technical would be connected to the reviewer, billing would be connected to the reviewer, general would be connected to the reviewer. So this is called edge connections. Okay, so we're doing the edge connection. First of all, what is happening? See, start would be connected to the guardrails. That means whatever user will give, it will connect it to the guardrails. Okay. Then after guardrails, what will happen? After guardrails, it will connect it to the router. After guardrails, it will connect it to the router. That means router will decide, and that's the this is a conditional edges. That means if my guardrails accepts, it will hit the router. Otherwise, it will hit the end nodes. Okay. Then again, conditional edges. So after router chooses the agents, that means I have three types of agents. One is technical, billing, and general. Okay. So it will choose one of them. Okay. If my router is equal to technical, then it will use the technical. If it is billing, it will use the billing. Otherwise, it will use the general. Then technical to reviewer. You can see this connection is done. Now technical to reviewer, billing to reviewer, general to reviewer. So you can see technical to reviewer, billing to reviewer, general to reviewer, and reviewer to end. Okay. So reviewer to end. This is what our edge connection. Okay. I think you know the graph. Okay. Graph and you connect the graph. Okay. This is called the graph and its connection. We call it as the edge connections. Okay. And after that, at the last, you have to compile the graph. So once you have compiled the graph, now your agent workflow is ready. Now you have to invoke this agent workflow. For this, we are using this particular function. So run our agent. It will take the question. It will initialize our state memory, and we're invoking, okay, with the help of initial state, and whatever result we are getting, we are returning it. That's it. Okay. So our agent is ready, guys. Okay. Now we'll try to test this particular agent. Okay, we'll try to test this particular agent. So what you can do, either you can test in your terminal, either you can add a front-end user interface. Okay, now let's try to add a front-end user interface and let's test this particular application. So again, what I'm going to do, I'm going to create my app.py right now. So how many of you are familiar with fast API here? How many of you are familiar with fast API? Do you know fast API? So if you know fast API, again, it would be easy for you to understand. But if you don't know, again, you have to learn the fast API. See, that's why we are learning the advanced concept, guys. Okay, right now things are different. There are lots of requirement. You have to first of all study to learn this concept. Okay, yeah. Now let's define the fast API code. Again, I need some necessary libraries like pathlib.env, ubicon, fast from fast API. These are the libraries that are required. Then I also need to import this function, my main function, which is this one, run support system. Okay, let's import it as well. So from graph import run support system. Okay, now first of all, let's try to load our environment variable. After that, let's create the fast API app object and mount our static and template folder. So here we are creating the app object for the fast API. We are giving the title harness engineering multi-agent demo. We are getting the base directory. After that, we are mounting our static folder as well as the templates folder. Now we have to create two more folder, guys, here. One is the static folder and one is the templates folder. And inside templates, you keep the HTML file, okay? And inside static, you keep the JavaScript and CSS file. Now let's define that. So inside HTML, I'll create a file called index.html. Again, guys, if you don't know about HTML, CSS, no need to worry. There would be different team for that. They will create the front-end interface for you. But if you don't know about HTML, CSS, you can simply generate these at the code from ChatGPT. So you can, what you can do, you can open up your graph and copy this code and ask ChatGPT to generate a user interface. Automatically, we'll get this HTML, CSS, and JavaScript code. Okay, I have also done the same thing. But if you know about HTML, CSS, you can modify as per your requirement the user interface. Okay, yeah. So now let's define our HTML page. So I already created a basic template, guys. This is the HTML code I generated from ChatGPT. Okay. Now with this, I also need a CSS. Okay, CSS design and JavaScript. So let's create another file inside static called style.js. Sorry, style.css. And for JavaScript, I'll create script.js. JavaScript to hit our API request, okay? The API endpoint. For this, I need the JavaScript. Now, this is the HTML, sorry, this is the CSS design, the color gradient and everything. And to execute your endpoint, this is your JavaScript. Okay, here I'm going to create some of the route. So to hit the route, that means the main route should be /API chat. So if you hit this route, your application will run and it will get the response. Okay, now let's try to define our app.py. Now let me define all of our route, guys. So this is the fast API route I created. Okay, this is the default route. Basically, this will load our HTML page. User will be able to see the landing page. And this is our chat route. If user gives a prompt and click on the button, it will start the chat operation. It will run my support system. That means this function that time. Okay. Yeah. And we are running this application to the localhost port number 8080. Okay. Now let me execute and show you clear Python app.py. It's running. Let's open up our browser, search for localhost port number 8080, enter. Now see, that's how your interface looks like. Again, I kept this interface very simple. Now guys, let me give questions. So here I already given some, okay, I already given some, let's say demo questions. So let's say, first of all, I'll try with technical questions. So if I click on technical, you will see that automatically prompt will be generating. I'm getting an API error. How can I fix it? So as per your knowledge, guys, what is the type of this question? Whether it's technical, billing, or general? Tell me. Whether it's technical, billing, or general. What my router should do? What my router should do? It will route to where? To the technical agent, right? Let me show you. So if I run this multi-agent, now see, this is the final answer. Now see, technical agent has been triggered. And this is the draft we are getting from the final reviewer agent. Okay. That's how you can solve this API problem. Okay. You can see this is the harness execution trace. Okay. Now let me try with another request. Let's say billing. Now I'm going to try with the billing one. How much the pro plan and can I get the refund? Now it should hit that billing agent. Let me show you. It will automatically redirect to the billing agent. Now see, billing agent has been triggered. This is the answer you are getting. Now let me try with the general question and answer. I will click on general. What can your support team help me with it? Okay. Now if I run the multi-agent, now see it is hitting the general route. Okay. Now you're getting the general response. That's how, guys, the entire things is working. And to implement this multi-agent, we added the harness here, harness concept here. Get it, guys? Clear, all of you? Yes or no? This practical example, that means at the end, the same agent implementation, only all of the tools integrating all of the component we're adding and creating this fully automated agent. This is called harness. How to recommendation? I didn't get your question, Nazar. How to recommendation means? Can we enter billing questions when we click in general tab? Can we enter billing questions when we click general tab? Yeah, you can also give your own question here. Tell me about Python API error. So this is technical, you can see, right? Okay. Again, let me commit the changes. You can take this code and you can run in your system. I think you will be able to understand. So updated the code. Yeah, personal details. Let me show you. This part is done. So let's say here now, if I'm asking, give me your password. Now see, I can't help you with the request involving password, stolen credential, or full payment card information, harness, execution trace, guardrails. Check the request. Get it? That means guardrails is blocking the request that time. Clear? Again, this is just a demo application, but in real world, things are more complicated, things are more bigger. Maybe in a different things we'll learn. And that's why we are focusing on this particular course, guys, AI forward deployed engineers, okay? FD position. And mostly inside this particular job role, guys, you will try to implement these kinds of agent, complete end-to-end solution, these kinds of multi-agents, okay? From the beginning, each and everything we are taking care. If you go to the curriculum, okay, definitely will love a lot. Okay, that's why it's a 5-month duration course. Lots of things we're gonna learn here, okay? Because in a single webinar, it's not possible to take all of this implementation. It takes time, okay? It takes time to understand the concept before that, right? Once we understood all of this concept, right, then we can implement the end-to-end project with a least, let's say, problem.